the ones who consider ourselves cool, the computer scientists, we were able to talk to machines the way others couldn't. We wrote code in languages like Python, and those who couldn't write this code got jobs that paid less, right? In many instances. Now, what we are finding is that, well, we don't really have to write code the way we used to. We can now write English and provide that to AI, and the AI can generate this code. And a lot of people are saying, well, should I really be training in computer science anymore if these jobs are going to be at risk? There's also evidence that by using this AI-based, what is called vibe coding, um, companies are getting a lot of benefit. So Airbnb suggested that they had to do some code migration. They had said or estimated it would take 18 months to do that code migration using human beings, but they were able to achieve that in 6 weeks when they collaborated with AI. So, given the benefits that AI is bringing, it seems impossible for us to stop AI from entering the workplace. And so, my suggestion is that rather than trying to stop it from entering our work environments, we should do what is called developing a growth culture or a growth mindset. And you don't have to trust me on this. There are greater people who talk about these things. Satya Nadella, probably one of the most famous Indians right now, the Microsoft CEO, says that I am also defined by my curiosity and my thirst for learning. And that is the underlying requirement for anybody who's going to be successful tomorrow, whether it's in their job or in their life in general. It's going to be their curiosity and thirst for learning. He says, I buy more books than I can finish. I sign up to more online courses than I can complete. I fundamentally believe that if you are not learning new things, you stop doing great and useful things. So, for a lot of you who are early in your journey of learning, you're completing your degrees, have completed your degrees, it's important for you to realize this is not the end of learning. I've been lucky enough to have been in the area of artificial intelligence for the last 32 years, but every day I feel that there is so much I don't know. There is so much development happening. And so if I don't invest daily in learning new things, I am going to become irrelevant very quickly. And that's going to happen to you as well. Now, why should we believe Satya Nadella? Well, if you're into financial gain, then we can look at what happened. When Satya Nadella took over Microsoft in 2014, the price of the stock was $36, and you can now see that the price of that stock is over $400. It is this growth mindset that he changed within the organization as a whole that has got Microsoft to where it is today, where it is actually a substantial shareholder in OpenAI and is producing a lot of great AI-based software. So why is it that this is happening, and what do we do to try and manage this disruption that is happening with AI? My suggestion, and you've already taken the first step, is to make technology your friend. Develop a passion for learning, but to learn in such a way that you can be a problem solver. To not just learn for the sake of learning theory, but to learn how to utilize that theory into applications. And think deeper about the applications that you are developing. What is the barrier to entry for somebody to come and disrupt your business? These are all things that we have to think about. We have to be passionate about succeeding if we need to succeed in our AI-driven world. Now, in the last while, yesterday specifically, you have been learning some techniques that we call narrow AI. You probably learned that AI learns from experiences. Oops, sorry. Those experiences look like data. Each row in this data here is one experience that we're giving the artificial intelligence. Here, I'm taking an example, a very narrow example of defining how much premium a person must pay when they are applying for health insurance. They fill up a form. We are saying it's very limited in terms of what data we are asking them for, their age, their gender, their body mass index, the number of children they have, whether they're a smoker or not, and where in the United States they live. This data is from the United States. And based on this input data, which we will call X with this arrow on top, which is a vector, what we are doing with machine learning is we are learning a function that, given this input, it can predict a real valued output variable, that output variable being the health insurance premium that they need to pay. Why do we call this narrow AI? Well, once it has actually learned this function, and in fact, it's an approximation of the function that is being used by humans today that are developing these models that predict the charges. It can only really use this one function to do a very narrow job. And that's why we refer to it as narrow AI. So from this data, we produce a model. And any user of this model will provide the input data typically as a JSON file. If you don't know what JSON is, it's not important. And what we predict back is the premium that this person should pay. Right? The reason why I've got JSON here is typically the interactions happens through an API. And what we are doing is we are monitoring the behavior of this model. We are then updating the model and continuously learning and improving on our predictions. This is where we've spent a lot of time over the last 15, 20 years. Most of the applications have been around this narrow AI. But what has changed in the last few years is our ability to deal with natural language. Now, if we look at what's happening here, this function is really a probability function. It's saying, what is the probability of Y given the input? Y here, we will make some assumptions about. Maybe we define that as being a normal distribution or whatever it might be, right? We make some what are called functional form assumptions as to what is this probability function look like. And there'll be some parameters that we are learning that truly defines what this probability is. Now, when we talk about natural language processing, we are doing something similar. We are, as human beings, we have some concept in our brain. Maybe this human being here has never seen an elephant before. He went to Africa or to India. He went on a safari and he saw an elephant, and he went back home to a country that does not have elephants. Let's say it's England. And his friend, this lady here, doesn't know what an elephant looks like. Now, this concept of an elephant cannot be transferred from one brain to the other directly. So what is this human being going to do? He's going to come up with a set of words in English that describe this concept. And this person here is listening to this stream of words, right? Word one, word two, word three, and is creating an image of what this person is talking about. Now, the problem that we had was that natural language was typically very ambiguous. It wasn't a great mechanism of being able to communicate. And because it was ambiguous, you know, when we had to talk to computers, these um, languages were found to be too difficult. And that's why computer programming languages were created that had a very small vocabulary, and they allowed us to use that vocabulary and give a recipe of what computation had to be done by the computer to the computer. And the computer then followed that recipe and executed it and gave us the output. Now you can see here that the human may have been describing an elephant, but this lady here, based on these words, is now created a concept which is more like a fan rather than an elephant in their mind, because maybe they're talking about these big flappy ears. And she starts to know, she knows what a fan is, and therefore she thinks, oh yeah, fans also have flappy ears. So the fact that we have now been able to learn natural language, as in give the power of talking natural language with a computer, is actually a huge leap for the work that we've been doing in artificial intelligence. And so before we actually get into how that's done, and the whole day I could see you're doing a lot of lectures on transformer models and all sorts of other models, let us look at what is happening as a result of us being able to learn um, how to speak to computers in natural language. And one of the big questions, like I mentioned earlier, that is being asked is, should I really be learning programming languages? And again, taking a post of Andrew Ng's, he has no doubt that knowing how to program is still very, very important, right? Learn about AI and take control of it, because one of the most important skills in the future will be the ability to tell a computer exactly what you want so it can do that for you. Coding is a great way to do that, right? So if you're wondering whether you should be learning coding, well, here is not just me saying it, but Andrew Ng saying that you should be learning it. What the large language models, which are essentially the AI that is able to speak English, have started to now do is participate in our jobs with us. So here is an example of a teacher that has been teaching forces and motion to their class 9 students, CBSE students, now can actually say to the AI, you are a CBSE school teacher. It's giving a role to the AI and giving it a location as well. And then saying, based on the fact that they are class 9 students, tell me how I should go about teaching forces and motion. They may say, could you give me some examples that I can use during my lesson that will resonate with my students? And actually then sets out some further context to say that these students are big on cricket and athletics, right? And so it picks up examples from cricket and from athletics. But we can't be outsourcing our thinking to AI. And the reason why we can't be outsourcing our thinking to AI is that AI makes mistakes. And let's call a mistake rather than a hallucination. The term hallucination is very much a marketing term, right? Because humans that hallucinate, we lock up because we think that they have some psychological issues. I'm not suggesting that is the right thing to do. But when it comes to AI, by saying that it hallucinates, we are making it more human-like. And so AI companies that are talking about AI hallucinating are hiding the fact that AI is actually making errors. And so one error that I found in its description here was when a fast bowler delivers a ball, the ball keeps moving until it is stopped by a bat, wicket, or a fielder. Well, that's not true, right? And so I question it back. Surely your example isn't true. And it comes back and says, you're absolutely right. It's not going to because of friction and resistance, air resistance, and gravity, right? There are forces that are working on it. And so you can have this conversation, and this is the way you should be using AI if you're really trying to get valuable information from it, rather than just accepting whatever it has provided to you. Now let's get into the technicalities of it. The problem that we have when we are trying to speak English or get AI to speak English is that we are always trying to figure out, given a sequence of words, what is the probability of the next word being sun, for example, or being apple, or whatever other word. Now, the English language has more than 1 million words in it. And if we think of a sequence of I words that have already been spoken, it means we need to know the probability of every word in the English language, which there are 1 million of, for every sequence that may have passed. And so if we think of how many possible sequences can we have of I words, where each word can be one of 1 million, then it's 1 million to the power of I. And even for small sequences, this can become a very large number. And it's not possible to learn that many probabilities from data. And this was the stumbling block. And so what researchers did was they made unrealistic assumptions, like the Markov assumption that said that the next token, the next word, is based only on the last token. And if you remember a few years ago, you had predictive text in your phones. It wasn't very useful. It could predict a word. Very often that wasn't the right word. And so it wasn't a feature that was used very much. And the reason was the fact that if you have the apple sat on a table that was next to the, what is this word going to be? Now, if I decide to use only the last token, it could be pretty much any word. If I'm using such a long sequence, again, the possibilities are large, but the number of words that can fit are much less than what they would be if we had only the word the available to us. But to be able to predict that, we need to know the probability of every word in our vocabulary given a long sequence of words out here. Right? So to achieve this was impossible, really, given the breadth of words that we had in the English language. Now, one breakthrough that came in a few years ago was this idea of word embeddings. The idea that if we have a sequence of words here, and we were assuming that it was still the word the that was going to predict the next word in the sequence, earlier what we would do is we would input a one hot encoding, which was a million dimensional vector with a one in that one index that corresponds to the word the. And we would have a multi-layered perceptron or some kind of a neural network that would learn the weight matrices. I know you've done some deep learning yesterday, so I'm assuming that you're following this piece, and are able to then predict the probability of every word being the next word in this sequence. But what we had a problem with was still the fact that this was 1 million in dimensionality, as was this output. So what researchers started to think is that rather than having this 1 million dimensional vector, can we find a vector representation for every word? And maybe we have d dimensions here where we have numbers in these d dimensions that somehow correspond to the word Spain. Now, when we think about countries, we could think of it geographically, right? We could say that this is the latitude and this is the longitude. And based on that, we can put countries into this two-dimensional space. Countries that are close to each other geographically, so European countries will be close to each other, and Asian countries will be close to each other, and we are all good. But what about words like rat and mouse and tiger? There is no way for us to map them onto these dimensions, or there wasn't a way until a Google researcher came up with this idea of word2vec, where what he said was that we have a lot of text that is available to us in digital format, and every word in this text has context, has words around it. And I don't know whether you were told this by your mother or not, but when I was a child, my mother always said to me, you are known by the company you keep. So if you stick around with boys and girls that are considered to be naughty in the neighborhood, you will be considered naughty. If you are with good children that are doing the right things all the time, you will have a reputation, or you will be known as one of those good kids in the neighborhood. And so this researcher used the same principle. A word is known by the company it keeps. So for every word, he said there'll be multiple occurrences. If we look at all the text on the internet, there may be millions of occurrences of the word stays. If we look at all of the words that are close to the word stays, and we create a probability distribution, right? So we are saying there's word 1, word 2, till word 1 million. There'll be a small number of words that have a non-zero probability of occurring within the context window of the word stays, right? So similarly, for mouse, we would have a context window probability distribution. We'd have one for rat. And we would expect these to be very similar. Why? Because rats and mice are essentially similar animals. They are seen in similar habitat. They cause the same trouble if they get into somebody's house. But a tiger will have a different set of words in its neighborhood, maybe something to do with the jungle, maybe to do with other wild animals. So if we could now look at calculating a distance between these probability distributions and using that somehow, that distance, and mapping it into a two-dimensional space, or maybe even a higher dimensional space, we should see tiger here and rat and mouse here, right? So, and then you may have dog and cat out here, domesticated animals versus wild animals, elephant. And so, by using this mechanism, what we found was a set of coordinates for every word in the English language, right? That looked like it was making sense. So in two dimensions, we can see that hamburger that has the coordinates something like minus 1.58 and 1.05 maybe, is close to other food items like meatballs and falafel and so on. And similarly, dogs and wombats and koalas, all of the animals have different coordinates. And what that means is that now, rather than when we are inputting a word into our neural network, rather than inputting a 1 million dimensional vector into the neural network, we can now put in a d-dimensional vector. Now, I continuously am coming back to this d, is because in the models that have been developed in artificial intelligence, this d is typically 100, 300, 1024. So they're large, right? They are 1,000-dimensional representations of a word. Now, for a human being, even visualizing in our brains 1,000 dimensions, why 1,000? Even 5 dimensions or 4 dimensions is impossible. We live in a 3-dimensional world, and therefore we can visualize 3 dimensions. But to a computer that lives in an infinite kind of space, 1,000 dimensions is not difficult to deal with. And we have mathematical methods for dealing with higher dimensional data. We can't visualize it as such. So the representations are in much higher dimensional space than what I'm showing here. Here I have reduced the dimensionality to 2 dimensions, and therefore you can see that a monkey or a wombat actually is a good example, which is a wild animal, is close to a dog. And it's true, they are from a similar family, but there isn't a further differentiation between wild animals and domesticated animals. But actually, in that 1,000-dimensional space that these words are stored in, you're actually going to see a sizable difference or distance between a dog and a wombat. So we've lost information by representing it in 2-dimensional space. But even while we have done that, the problem that we had with neural architectures that were predicting the next word was that it was still dependent on only the last word here. And so researchers evolved from using these multi-layered perceptrons to using what are called recurrent neural networks. And the recurrent neural networks, if we look at one part here, looks exactly the same as what we had here. The difference is what we are seeing is happening in this part. So what we are doing here is we are feeding one word at a time. Rather than having it as v-dimensional, the difference is that now we are doing d dimensions going in, the embeddings. And these d dimensions are then being processed, and we're coming up with some representation here, which is we can call it our memory. And as each word gets fed to the neural network, this memory is being updated. So you can see here also the memory that is going in here is actually an updated memory representation of all of the words that have gone since in the past. And now we have this new word, that is being fed in, and it is updating that memory. And now, because we are saying what is the next word, it is predicting words here. So in addition to getting the input of the word it is also using this memory of all of the words that have gone in the past. And this was the state of the art in modeling natural language until 2017. And in 2017, there was a paper by Google called Attention is All You Need. And this paper proposed a different architecture called the transformer. And the transformer architecture is what all of the recent generative AI is based on. And you will be learning in depth what this architecture, how it works. I'm going to give you more of a conceptual introduction to it. Now, even in the days of recurrent neural networks, researchers had come up with this idea of an encoder and a decoder architecture. And the encoder provided some information to the decoder. So if somebody says, what is the temperature in Delhi today? This natural language is going to be encoded by the encoder. And what the encoder is doing is it's only generating this representation of all of the text that has been fed in. All of this text here is going to be represented. Remember, each word is now represented in d-dimensional space using embeddings. Those embeddings are getting updated with every new word that gets fed in. And so we can call this here an embedding of the sentence, whatever has been spoken up until now. And now that we have, and this can be d-dimensional, it could be dm-dimensional, right? Because we are getting lots of words. We might feel that if one word needs d dimensions to be represented, maybe we need more dimensions to represent a full sentence. So the dm-dimensional vector gets passed by the encoder to the decoder. And now the decoder uses this as input and starts to produce word 1, word 2, word 3, until it comes to a special word that is predicted as end of sentence. And that is how it generates output. given some input out here. So this encoder-decoder model, if we actually go back to this representation that we had of natural language and two humans talking to each other, in the brain, you are saying knowledge is encoded. And what is it encoded as? As weights on connections between neurons. So you have neurons that are our brain cells. They're connected to each other. The output of one neuron goes as input into the other neuron. And the strength of that connection is what is the weights. So from that internal representation, when we are converting it into a set of words, what we are saying is we are decoding. Our knowledge is being decoded and producing these words. And then when this person here hears those words, they are encoding it back into that representation here. And when they have to respond, they are now going to decode and produce their response to what this person has said to them. Right? So that was the kind of thinking behind these encoder-decoder models. And here, what we have is, this is the encoder part of our transformer. And this here is the decoder part. So when you read about these large language models, you'll see that some models are encoder-decoder models. Some are encoder-only models, and some are decoder-only models. And let's very quickly discuss why there are these differences. The original transformer paper was aimed at machine translation, translating from one language to another. So the input is English, we want to produce French. Now, if we are to do something like this, there's a clear distinction between what is the input and what is the output. And so they use this encoder-decoder model, where one of their largest contributions was this idea of multi-headed attention. And you will learn about that when Akshay speaks to you next. So I won't go into detail about it. But what they removed from the encoders that we had earlier was the recurrent behavior. The recurrent behavior that we are referring to here is where we had one word being fed into the neural network at a time. And the problem with this, of course, was the fact that we could only process the text sequentially. And anything that is sequential is going to be slower than what we can do parallelly. Because the output here is dependent on the current word and the history that has been passed in. Obviously, we can't do this processing without knowing the history. So what they did here was they said, we will feed in all the words parallelly and independently. But we will also feed in something called positional encodings. That is a representation of what is the order in which the words appeared in the input. Why? Because words that are close to each other are likely to be more related than words that are far away from each other. But there are examples like I took my dog for a walk last night and he ran after my neighbor's dog. Now, the word he here, we have to associate with my dog, right? And there is a distance there between them. So it isn't always the fact that we can understand who this he is by just looking at the closest neighbors. But there is a bias towards, well, the he running, clearly it is important to understand that what was running was he, right? And so there is this proximity bias that exists in the analysis that we want to do. And therefore, these positional encodings were added in to bias similarity of words based on them being close to each other. But by not taking into account the history, now these words were being represented completely independent of each other. And if we have the word apple, knowing that the next word is laptop helps us disambiguate that this is not the fruit. It is a piece of electronic. So we know that the representation of apple, which started off as being only one vector, both for the fruit and for the electronics gadget, we have to somehow change this representation based on words that exist in the sentence that help us disambiguate between the fruit and the electronic gadget. And that is what is happening in this attention layer. So we are now, because we have the full input of the sentence that we are wanting to translate, I put my Apple laptop on the table. And I want to know how I would say this in French. I want to be able to take maximum use of this sentence in generating an encoding or a representation for each word so that the decoding happens accurately. If I am only doing a decoding, so I'm using a decoding only architecture, what is different about it is that we will take our English sentence and we will say this is now the end of the input. Now you have to start generating output. And the architecture will generate this first French word only based on what is before it. And then it will generate this next French word based on anything that is before it, either the French or the English input that we had. So to figure out what it should generate next, it is only looking to the left. And because the architecture is the same, whether it is now generating information or whether it is consuming what has been said, even when it is learning how to represent the word apple, it can only look at words to the left. And so it doesn't seem laptop. And therefore, the encoding of Apple doesn't take laptop into account. And that is one of the disadvantages of decoder only architectures, is that it can only look at the past. But given that our input has been already provided, why not leverage both words on the left and the right to understand what Apple is? It seems to make sense to do that, right? And we can do that if we separate out the architecture and create a difference where we say the encoder architecture is going to use multi-headed attention and is going to allow all words, whether on the left or the right, to contribute to what is the representation of Apple. But the decoder, because the decoder is now generating information, it can't know what is here because it hasn't generated it. It doesn't have the ability to look down here. It will only look to the left. And you can see that we are feeding into the decoder. There are many arrows here, right? What are these many arrows? They are basically all of the words, embeddings that were input here with the processing that has been done. So Apple may have been input as a representation that could mean the average of apple, the fruit, or Apple, which is New York, because they call New York the Big Apple, or Apple, which is the electronics company. But because we have seen the word laptop here, by the time it comes out here, the representation of Apple has changed, where it is now representing just Apple, the electronics company. And that is what is being fed in here. So to produce the words, we are giving inputs, which are the vector representations of every word in English, to the decoder to start to generate the words that it has to generate. An encoder-only architecture like BERT only produces these encoders, and after that, you can train on top of that encoding any function that you want. So for example, if you wanted to build a classifier that said, is this a question? Or is this a hate statement? The encoding that we get from a model like BERT can be input into a multi-layered perceptron, which then converts that into a classification, right? And so encoder only, because it only encodes, does not generate, is not generative. But both a decoder, an encoder decoder, or a decoder only, both of these can be generative in nature. Now, while we've talked about text leading to text being generated, we know now, and we in fact saw an example earlier of how with text we can generate images. In the end of the day, the process remains the same. Here, we are encoding the text and coming up with some representation of what is the meaning of this text. And we are then using it with a different decoder that is producing an image rather than text, right? Now, there are various approaches there that have been proposed for generating these images, and we don't have time to go through all of those. But I want you to recognize that once we have taken some text and represented it in this embedding space, which you should really think about as being a representation of concepts, Then, depending on which decoder you use, you can either generate the French equivalent of that text, or the Punjabi equivalent of that text, or Gujarati equivalent of that text. So it's decoders that are translation oriented. Or you could take a decoder that can generate images where it's trying to figure out what's the next pixel it should put within an image, right, at a high level. Or it could be to produce music or speech, right? Because in the end of the day, speech also is a signal, a very high frequency signal, something like this, right? When you look at the speech represented in the time domain, you will get it to look something like this. And all you are doing is producing a sequence, not of words anymore, but maybe of sounds. And when you put those sounds together, you get the speech that is maybe just the uh, text to speech type applications where you want a synthetic voice to be speaking and saying the words that you have typed. Right? So, this is the core foundational building blocks that I wanted to share with you today. And hopefully, you have um, kind of at least conceptually got this idea that these architectures are encoder decoder based. If you have a decoder only, it can actually encode at the same time as decoding. So, but the easiest way to think about it is I encode something that is input to me. It could be an image that I'm encoding, and I'm producing a description of it because I have a decoder now that produces text, right? So once we have this architecture, all we need to do is feed it large volumes of data, and that data then helps during the training phase to learn the right weights within our neural architectures that can produce very accurate outputs, as we can see today. Okay, so I shall stop here. Um, and I'm happy to take any questions if there are any. Okay, well, in that case, I shall hand it back to Rakshita. Rakshita, I'm sure we're at the time for the next talk. So thank you very much for the opportunity to speak to everyone.
Thank you, sir.
Thank you so much, sir. So I hope you all loved the session, and if you have any queries, you can put down in the chat box. Else we will be starting with our next session in a couple of minutes. Okay. So let's just wait for a minute or two till our mentor joins. Okay, and for now, we will be having our session on From Next to Intelligence, Basics of NLP for LLMs. So let's just wait for the mentor to join.
Hello, good morning.
Hello, sir. Good morning, sir. So just a sec. Before we start the session, let me just give a quick introduction of what the session will be about. It will be from text to intelligence, basics of NLP for LLMs, understanding how LLM comprehend, generate, and transform human language. It will be given to you all by Mr. Jayaprata Chakraborty, who is a lead data scientist of Tatras Data. Over to you, sir.
Thank you. Uh, I'm I'm clearly audible, right?
Yes, sir.
Okay. Just let me share my screen. My screen is visible, right?
Yes, sir.
Okay. Yeah. Hello, everyone. So, as already it is, I mean, it already conveyed to you that what this session is about. So I'm just going to start that session. Now, so every day we interact with our machines, right? When we search something in Google or talk to Alexa or chat with some AI chatbot, right? Like ChatGPT. Now, the simple question is that how does a computer understand language? I'm talking about the text language because we human understand language very naturally, but machine don't understand the language, right? So machine only understand the number. Now, in today's session, we will discuss how this simple text get transformed step by step into intelligence so that machine can understand that language, that text, and able to produce new text, able to reason, right? That all you know, or most of you are actually aware of that large language model that we already used in our daily day life. So in this journey, from text to intelligence, the the branch of that AI, intelligent AI, is help us most is called NLP, natural language processing. So natural language processing is a branch of artificial intelligence that actually give the ability to the system to understand text, right? Now, how it works. So there are different aspects. We only consider the uh, one aspect, that how a text is going to be represented to the system. Because as I have already mentioned, okay, machine simply cannot understand or process the text data. So somehow we need to convert this text into number. That is the basic thing that all we are going to discuss here. So once we able to convert a text into corresponding number, then we can train a model with those text, and we can build a different thing out of that. We can uh, build a different intelligent text processing model out of that, that nowadays we all see, like ChatGPT or other form, right? So the first basic question is how we are going to convert a simple text into the number. So all the journey starts from this point. Now there are lots of way to do that. So we are going to discuss three basic fundamental strategy. One is that bag of words, another is TF-IDF, and word embedding. The objective of each of these methods is converting a text to corresponding number. So somehow we have to represent a text, a word into a human, a machine interpretable form. And right now, bag of words is very simple technique, very old and very simple technique. So it says that suppose you have a text, right? So within that text, if you convert the text in individual tokens, so if this is a single text, this movie is very good. Now, and also that entire text also contains second sentence, that is this movie is very boring. So these are the two sentences that create the entire text. We find each and individual token out of that and create a vocabulary. Now, in within that vocabulary, we have this kind of token. So this is a token, movie is a token, is a token, very is a token. So these are individual token, right? And to convert this sentence into a corresponding numerical form, we just compute the frequency of the token appear within the text, right? So for example, if we consider this to review and consider single text, the total number of vocabulary including this two sentence is something like that, 1 2 3 4 5 6, right? Total number of vocabulary is 6. Now that means each and every sentence or text is going to be represented with 6-dimensional representation, and this is called embedding, right? So this representation is called embedding or vector. So we have to we are going to represent each and every sentence in a 6-dimensional numerical form. And how those embeddings is going to be generated? The very simple way is that just count the number appear within, count the token appear within that particular sentence and generate that embedding. So for example, for this review one, the embedding is looks something like this. So this word is appear in this sentence with the frequency 1. So we put a 1 at this point. Similar for movie, similar for ease, right? And if it is not appear anywhere, any one of this vocabulary is not appear within this text, corresponding value will be 0. So that means boring is there, but with 0 frequency, something like that. This is the representation. So in this way, if we going to represent a sentence, then it looks something like that. So review one, the representation for review one is something this binary representation in this form. So 1 1 1 1 for all of those words and 0 at the position of the boring. Right. So if you consider this as an embedding, so review one is represented by this numerical form. Review 2 is represented by this numerical form. If there are some other sentence also, so this vocabulary got some other tokens also. So dimension is going to be increased, right? And each and every sentence will be represented by in this manner. And it is pretty simple way to represent a sentence in corresponding numerical form. But there are some limitations in this way, in this process. If you look at the representation of the sentences, now you can see that. So in this first review, all of this word has a value 1, right? So they have, in the embedding, they have a very high amount of contribution. If some within this particular sentences, if some of the tokens have more than one frequency, then those value is going to be higher and higher, right? So in the entire representation, the contribution of those words are, I mean, going to be very, I mean, very highlighted, right? With very high values. But the issue is something like that. If you look at these two sentences, what is the actual important word in these two sentences? If I try to understand the meaning of this sentence or difference of this sentence and all these things, uh, what is the token that I am going to focus only? The only, I mean, differentiable word is good and boring, because all the other tokens are same in the both sentence. So this movie is very, these are actually common words, right? Only distinctive words is good and boring. So if I try to understand or analyze these two sentences, okay, I mean, what is the relation between these two sentences? So, I mean, as a human being, you are only focusing in this particular word, right? So this sentence is saying something, I mean, about good. This sentence is saying something about boring. But in the representation, all the other words along with the good have the similar kind of weightage, right? So this is the very, I mean, common problem with bag of words. So any question from this particular part? Uh,
No, sir.
okay. If you have any question, you can unmute yourself and ask, right? So we need to introduce something that only focus on those tokens that are really matter, right? And how can we decide that? What should be the strategy to do that, to achieve that goal? Okay, um, we only focus on the important tokens. So a common assumption is something like that. The word is rare, appearing rare in the corpus or text. That could be important thing, right? If in the multiple document, the common words are actually very less important, right? So if I try to compare those two documents or compare those two sentence or some compare those two text, we only try to focus only those words that are actually uh, appear in one document that not appear in the other documents, because the other common words are, I mean, present in both the documents. That does not help you to understand the relationship or the difference, or if you try any kind of computation between those two documents, right? So for example, in the corpus, you try to, I mean, suppose you have a corpus with the review, all the reviews, right? Now you try to find out the reviews that has saying something good about the movie, all the reviews that has saying, I mean, very I mean, good reviews, right? Or boring reviews or bad reviews. If you try to classify those two kind of reviews. Now, based on this numerical representation, you can compute some similarity operation and find out all the other embeddings of other review that are pretty much similar with this embedding. Now, since all these important words has high weightage, these are going to be play a crucial role to fetch the other documents, right? So you end up with some kind of decision that don't help you to classify those kind of good reviews and bad reviews, because these unimportant, very generic words are going to be more dominant to find out the to analyze the document, or to fetch the documents through these embeddings, right? So by this intuition that rare is important, we move to the next section, next methodology, that is called TF-IDF embedding. Now, TF-IDF, the full form is term frequency and inverse document frequency. So there are two parts. One is term frequency and second is inverse document frequency. So we are computing to different score for each and every word or token present in the text, and by using those values we are going to find out the final embedding, right? Now, what is term frequency? Term frequency is very simple. How you compute term frequency? So in your vocabulary, if a token or word appear within a document, so that that frequency will at this point, and it is divided by the total number of vocabulary. So for example, in the previous example, if you consider the previous one, so there are total number of vocabulary is 6, right? And this token is appear within this sentence one time. So the term frequency of this within this set for this sentence is 1/6, right? So this is the term frequency. So that means a term appearing within a text divided by total number of terms. That is the formula to compute the term frequency. So that means if a term's appearing with a high frequency, the term frequency value will be higher for that particular token, right? So if any words are appearing more than 1, so it will be 2/6. If it or 3/6 or 5/6, that means based on the frequency, how many times it appear within the text, this term frequency is going to be higher and higher. So that is one part. And second part, that is very important, that is called inverse document frequency. Now, while we compute term frequency, it actually we are only considering one single document, right? And when we compute the inverse document frequency, we are considering all the documents present in the corpus. Now, what is the formula to compute that? The formula is very simple: log of number of documents divided by number of documents with term t. Okay. So if a word, total number of documents, how many total number of documents you have, divided by the total number of documents that has that particular term, and we perform a log operation on this. So what is the intuition between that? Behind that. So for example, if you consider this token, this, the movie token, for example. Right? Now, how many documents you have right now? You have two documents, right? So review one is one document, for example. Review two is second document. If you consider these are two separate documents. Now, so in this formula, the total number of documents is 2. And in how many documents this movie term has appeared? So movie has appeared in the first document as well as in the second document also. So that means this value, number of documents with term t, is also be 2. So it is a 2 by 2, that means 1, and log of 1 is 0. That means if a particular word appear in all the documents, that means it is very generic term. So we forcefully reduce the score for that particular term. If it appear in the all documents, then the IDF value, inverse document frequency for that particular word, will become 0. If it appear less number of documents, then this value, this resultant value, the number of documents divided by number of documents with t, will be higher, and the log value will contribute something over there. So that means if a word or token is rare in the documents, it appear only one document or two documents out of the 1,000 documents, that means it is some important word. So we are actually going to increase the value of that particular token. And if this word appear in most of the documents, then it going to be very low. So term frequency we compute within a single document. If a particular word appearing most, with a high frequency in a text, that means it is an important document, important token. But if a word appearing in most of the documents, then it is a less important word, right? And finally, we are going to multiply this to score, right? And get the single score of TF-IDF for each and every token. So for example, if you consider this review 1 and review 2, these two documents, so this movie is very good. Here, the term frequency of these is 1 by 5 because it appear one time and there are 5 tokens. So it is 1 by 5 multiplied by log of 2 by 2 because this word appearing in both of those documents. So it will be 2 by 2. So when you compute the final score for this particular token, it become 0. Right? So all of these words that appear in both of the documents, the score, TF-IDF score for each of those tokens become 0. Less significant. You will see some value at this good and for this good and boring. Okay. Now if you put those, score and generate the final embedding for each of those documents, it looks something like that. Now here all the less significant words, value of those less significant words become 0, very low value. Only the distinctive words have some value. Clear? So now it's overcome that limitation of bag of word, where if a word appearing with high frequency and it got high weightage in the embedding, within the embedding. Clear? In this TF-IDF, we only consider those terms that are very appear in very high frequency within a, I mean, documents, and very rare in all the documents. That will be considered as a important word here. All the other words going to be, I mean, value of those words going to be very low, right? Now, if we consider this embedding, this only has some non-zero value at this good, right, and boring for the second document. All the other insignificant words become zero. So this is now our representation or vector representation for each of those documents. Now, if you perform some similarity computation based on this document, I mean, based on this embedding, it only consider those embeddings that has some non-zero value at this for this particular token, right? And it will able to bring a similar document, I mean, similar, that document that has similar kind of wording uh, with a higher accuracy. Any question or any doubt at this point?
No, sir.
It's clear, right? Okay.
Yes, it is clear.
Now, it also has some limitation. What is the limitation? I mean, representation of word into the numerical form with TF-IDF is also have some limitation. So Bagobot have some limitation. It TF-IDF obviously overcome those limitations. That means it now only focus on the important term within the document. That is fine. But still there is something it missing. Any guess, any idea, any observation?
So both negative and positive words have having same value.
I mean, for this example, it has same value,
Hmm.
but it will be different if these boring words appear, I mean, with a higher term frequency within this document also. I mean, it is not guaranteed that they are all always they have same values, right? Because it
Right, sir.
depends on this multiplication.
Hmm.
The limitation is something like that. When we I mean, compute this embedding, so I mean, if you look at the structure of this embedding, so these columns are represent the vocabs, right? Now this movie is very good or boring or any, so this column, these words can be in any order. I mean, we are collecting all the tokens, then individual tokens represent an individual column, and we put the corresponding values for those column. I mean, we compute the TF-IDF score for each of those tokens and put in within the in the corresponding column cell value, right? The limitation is here is that it does not consider the context, right? Context means in which the surrounding words, what are the surrounding words, what are the order this word are actually appearing. Because uh, I mean, if you have a large corpus, there could be a thousands of tokens. Now you are appearing those tokens, I mean, you are presenting those tokens randomly in the column, and you are computing the TF-IDF score for each of those word, right? And you put those word in I mean, put the score in within that particular cell and you get the final embedding. But this good, when you compute the score for this good or this boring, we are not considering the context, the surrounding words it appear within, right? The order, it is not considered over there. So that is one of the most important limitation here. So this core computation is not context aware. Okay. So that means if I looking at the individual words, right? For example, suppose I try to find out very similar words in from our vocabulary. Okay, similar words means similar with respect to the context. For example, uh, king, this word is very similar with queen as per the context, right? Because they are representing similar kind of thing. I mean, king and queen are representing some status, some, I mean, some designation, similar kind of designations. So in the vocabulary space, if I try to find out semantically similar words, I mean, semantically similar means, I mean, maybe they are not representing the same thing, but somehow they have some relationship. If I try to find out those kind of relationship, this TF-IDF is not going to help you, right? For example, suppose there are three words: uh, apple, banana, and dog. Dog and cat, for example. There are four words: apple, banana, dog, and cat. Now, if I try to understand the relationship, okay, so and somehow we able to represent each of those word in a numerical form. So dog has a numerical value, cat has a numerical value, banana has a numerical value, apple has a numerical value, right? Somehow I am going to I mean, generate some numerical value of each of those words. Now, ideally, what we, I mean, ideally, what should be the relation between them? Suppose if I compute the distance or the difference between dog and cat and dog and apple, what should be the closer to dog, cat or apple?
So cat.
Why?
Because of their nature of their like they have different features like hair is there like mouth shape and like the color because the fruits are having different
I mean, right. I mean, initial idea, something like that. They are actually animal,
right.
right? They belong to animal set. And if I compute the, I mean, if you compute distance between apple and banana, they should be less than distance between apple and dog, right?
Apple.
Because they belongs to similar kind of set, right? They are fruits. These are animals, right?
Yes, sir.
But that information, how we are going to capture that information? Okay, I mean, how we are going to assign the numerical value in such a way to each of those words so that this feature we got, I mean, dog and cat actually appear very close in the proximity, close proximity, and apple and banana appear in very close proximity, right? There is a distance between dog and banana, dog and apple, cat and apple, something like that, right? How we are going to impose the, or how we are going to assign the value in those words in such a way that this, we can achieve this goal.
So there are different categories. One is just a color feature. Second is as a appearance feature.
Yes, but you are actually considering the image, right? I'm not
Right.
considering right now the image. I'm just considering the text.
Okay, sir. Uh, okay.
So the simplest thing is that you need to consider the context.
Okay, sir.
On which context? On the what are the surrounding words of dog we
Right.
have? If you look at the thousands of documents that has dog word in it, cat word in it, apple word in it, banana word in it, you will find that the surrounding words of dogs and cats are pretty similar, most of the documents.
Mm.
And the surrounding words of banana and apple will be pretty similar, right?
Right.
So if you somehow capture this information, this context our information, okay, what are the different context that dog has appeared, that dog word has appeared, that will help you to understand the relationship, that you help you to assign a value or a set of value to, that will help you to uh, uh, I mean represent that text to its corresponding numerical form, so that this goal, that means dog and cat will be appear very close proximity, you can achieve that goal, right? So somehow you have to bring context in the picture. So having said that, researcher, they are doing more research and more analysis, and they came up with the new methodology, and that is called word to fake, right? So now,
Mm.
till now, these two, whatever we are actually discuss in this two method, that means bag of word and TF-IDF, we are actually representing the entire text to its corresponding numerical form. So review 1 is represented with this combination of values. Review 2 is represented with this combination of values, right? But a single word is actually represented with a single value only. It not capture other aspect of this particular word. So if we try to capture different aspect of this word, so this word should not be represented with a single value, it should be a combination of values. That means it should be also an embedding. So each and that means we are considering multiple dimension of that particular word, and then we represent that word in corresponding numerical form. That will be required, right?
Right.
So that means we need embedding for word also. So each word can be represented with some combination of number. Clear?
Yeah.
Right. Now here the I mean so idea to understand the semantic meanings of the word based on their context, we need this word embedding, because we need to capture different aspect, different dimension of the word, right? A word cannot be represented with a single value only. That does not capture all the aspect or dimension or all those things, right? So there are two important, very common approach to represent word into corresponding embedding. One is one hot embedding, and another is this word to fake method. Okay. Now, one hot embedding is very simple. One hot embedding is the, very fundamental uh, process that will we used to in very different aspect. But what one hot embedding is very fundamental process and very easy process to represent a word to its corresponding embedding, right? uh, what is that? That is very I mean easy thing to do. You just consider all the vocabs, all the tokens, just like you have done here, right? Now, if you look at this representation, now this is the representation. So this movie is very good. The movie is very boring. If you consider all the corpus, we represent individual tokens here, and we assign an index to it. So this will be the index of this is 0, the index of movie is 1, right? So each and every token has its corresponding index in the vocabulary. Now, so that means if you look at this column name, these are actually represent each of this word. I mean I'm writing index over there, but this 0 means that is it represent this word. 1 means it represent this word. 2 means it represent this word, right? So you are going to represent all the words to, to its corresponding index. Now, in the left side, I mean, in the rows, right now, we are writing the sentence. Now we are actually consider the tokens, individual tokens. So this movie is very good. All the individual tokens are there, right? And you put
And the
1
endings.
at the corresponding index, and all the
Right.
other index will be 0. So this is the simplest way to represent a word to its corresponding embedding. So that means if you have 6 tokens in your vocabulary altogether, so each word will be a combination of 6 values. That means each word will be represented by uh,
Six
six
indexes.
six indexes, right? So it is a 6-dimensional embedding. Each word is a 6-dimensional embedding. Clear? Where only one position we have 1, all the other positions remain 0. So this is the uh, simplest way to represent word into embedding, and this is called one-hot embedding. Actually, this one-hot embedding is not that much useful to understand the context, but this one-hot embedding is very useful to train different model that can able to understand the index, right? So I mean uh, it is not context aware, because this index could be anything. I mean the relationship between these two embedding is not identified by these embeddings, right? Because I mean someone can set the index 0 for this, someone can set index 0 for movie also. Based on that, those embedding is going to be changed. So whatever index you are assigning to each and every token, based on that, this representation will be going to change. This is not a fixed representation, this word. Okay. So but the important thing is that somehow we manage to uh, represent a single word to a combination of values. That means the embedding. And this is the first step. That is one-hot embedding. It's clear?
Yes, sir.
And obviously, the limitation is very obvious that for large corpus, this this I mean the vocab set will be very large. So the embedding size will be very large, and it's mostly a parse representation. That means only one position of those embedding will be 1, and all other values will be remain 0, right?
Right.
and also it does not capture the semantic meaning or contextual information. So we move to our next level from one hot embedding, and that is called word to fake embedding. Now, just try to understand that till now, whatever we have done, we are doing some, mathematical calculation. We achieve those goals with some mathematical calculation, simple mathematical calculation. We do not introduced any machine learning model. It does not involve any training, right? All those methods. It could be TF-IDF, bag of words, or one-hot embedding. Uh, there is no training involved. There are some static methods that just follow this method, you will get something, right? Now, in this word to fake embedding, we first introduced neural network because we need to capture the context of each and every word, and to capture that information we need to go through multiple document where those words appear with different context, right? And we need to train a model which will learn this information, because if you look into your corpus, there are thousands of documents. This cat can be appear with different combination of context. It is not that cat always have a similar context, same context, right? Always these cat are surrounded with these words. This is not the true. So you need to uh, look at different aspect, different context also. Cat can be appear within these words, cat can be appear within those kinds of words, cat can be appear within those kind of words. So considering all of this, finally you will going to represent a numerical form of cat. Like, so that means you need to train a model, numerical, a neural network model that will trained with thousands of data, thousands of text, and finally when it when it look all the examples, it will trained with those data, and finally it able to produce the proper numerical representation of the word that capture all the aspect, all the context of that word, right? So by looking at only single document, you cannot decide what should be the representation of this word based on the surrounding words. You need to look at different examples, different wording, different document where this cat appear, what are the other sentence, other words that appear in the close proximity, right? So what we have done in this process, that is very important and very easy to understand. So they set some context window. Okay. So this context window can vary. Size of this context window. If you try to look at the larger context, so you need to increase the size of the window. Okay. So here we set a 3 size window over there. And at this, at this point, you set some inputs and some output. So input is the and output is cat. That means the within the close proximity of this word the, one word will be cat. Similarly, one of the close proximity words of this the is chased, right? So inputs are that word that you are going to, target, that we are trying to represent. We are trying to find out all the context of this word, and output is what are the words that appear within the similar proximity. Close proximity, right? So this word the will go into the neural network, and in the target we set cat as a target. So whenever that neural network get the output should be cat. That is one training data. Second training data is that input is the, output is chased. So in this way, there are, if you are considering all the other documents also, so there are other words appearing in the close proximity of these the also. Based on that, this training data is going to be longer and longer and longer, right? So that means your model will learn, okay, when we get this word, uh, the output could be cat, output could be chased. So based on that, all the internal weights is going to be tuned, and it learn that, all the context of the corresponding word. Similar for cat, similar for chase. So this is sliding window kind of method. So you set a window with 3 size, you prepare all the training data out of this window, then you move this slide to the right, and then for within this particular window, whatever word are appear, you consider them as a very context, they're very contextually similar words, and you prepare next set of training data. And this, in this way, you are actually scan all the text, all the documents, right, and prepare your training data. So that means if you increase this window size, you are actually uh, looking for larger context, right? I'm not going to, very deep in this particular method. So the method is very simple. So each and every word is initially just going, just providing a brief idea about there. So each and every word is represented by its corresponding one hot embedding, because you already know one hot embedding, right? So for example, when we provide cat as an input, so what is the one hot embedding of cat? One hot embedding of cat is, sorry, it is not there. So in this sentence, if you consider, if you follow the same similar method of preparing
One.
one hot embedding, so you consider all the tokens, index them, and cat will be represented by a one hot embedding. At one position will be one, that same
One
index
index.
position will be one, and all the other remain zero, right? So you are actually representing each words with its corresponding one hot embedding. That one hot embedding is going to be set to the input layer, to the numerical, the neural network, because you cannot pass the text. Somehow you have to convert that text into the numerical form, then you can pass it to your uh, AI model, right? So that's why I have already mentioned that, okay, one hot embedding maybe is not that much uh, important by itself, but it is very important when we try to train some other models, because the basic representation technique, numerical representation technique of each and every word is one hot embedding. So you provide this as an input, and you looking for the output, corresponding output of this. When you set this cat as an input, what should be the output, what should be the output words present at the close proximity, that is chased, right? So this is your one hot embedding of chased word corresponding. You compute the loss based on your initial output. So you initially got this output, and you but you actually want this output, So based on that, you compute the loss, the difference, and with the back propagation, you tune all the weights over there, right? So your weights got trained. Now, if you pass different input that has cat in it, and with different target value, I mean different output, different context, similar context value, uh, your model got trained with all the data. Now, if you take out these weights for this cat, that will be the numerical representation of this word that is got tuned with different data, right? So this cat is represented with this two-dimensional vector, this weights. Okay. So it's looks something like that. Okay, I mean D is represented by WT1 and WT. The corresponding weights are these two. So these are the representation of this token D. This is the representation of this token cat. These are the representation of this token chest. Something like that, right? Uh, I mean,
So for weight one and weight two, which function sir you have used sir here for
weights
calculating?
weight one, weight two are to numerical value, right?
Okay, okay, sir.
So initially, I mean that's why I'm not going to in much details over there, because maybe I mean most of you don't have the uh, I mean understanding of how neural network works. So these are some initial value we set.
Mm.
Here we compute some
Yeah.
function, activation function over there, right? So while we passing this input, we are passing a linear combination of these weights and these input values passed through this particular node along with some activation function, right?
Right.
So 1 multiplied by WT1, 1 multiplied by WT2, something like that. And we add those values, pass it to some other nonlinear functions, and then we compute this probability. Okay.
Right.
And based on that, we actually compute the difference, and there is a process called back propagation where we tune this weight. So we start with some initial values. With this back propagation method, we are going to tune these weights in such a way that when in the next time you pass the similar this embedding, it actually more aligned to this output
How many iterations we can set for the back propagation?
as much as you wish,
Okay, sir.
depending on the architecture, depending on the data, depending on the volume of the corpus, right?
Right,
So
sir.
there are different hyperparameters that you need to be tuned, and finally you got the uh, output. We
Right, sir.
will discuss. I mean, it's very with all the mathematical explanation also in maybe in future. But for the time being, you just keep in mind that this cat. I mean, this is the method. This small numerical neural network is actually capture the context of this particular words, individual words, and based on that context, the numerical representation we have for each individual tokens. So this is called the word to wake embedding, word embedding, right? Now, if you consider the similarity between this cat and this mouse, they will become very similar to each other, right?
Right, sir.
Because they are, I mean, appear in the close proximity. Similar kind of surrounding words will be there for cat and mouse also. Uh, but there are some actually limitation also there, because after completion of this training, cat is always represented by these weights. I mean, once your model got ready, whenever you are finding the embedding for cat, you always got this embedding, right? So these embeddings are static. These representation are static. Maybe it comes from the looking all the other surrounding words, but this is static. Okay, so that means, for example, the words bank, right? So bank has a same representation, single representation over there, right? But bank can be appeared in different context. I mean, for example, river bank is something different than financial bank, right? So when this bank appear after this river word, it has some other meaning. When this bank appear after this financial word, it has some other meaning. But in what to wake model, the approach that they are take, finally bank has a single representation. It is, I mean, whether it appear after river or after financial, it actually don't consider that information. It look all the context, all the document, and finally it actually represent the word with a single numerical representation, right? For example, apple, right? Apple, I mean, if you compute the what to wake embedding of apple, you will get a single representation of apple. That is fine, right? Now apple can be differ by
Mm.
its meaning where it is used, because apple can be considered as a fruit also, apple
Yes.
can be considered as a product also,
Yes.
right? That information is not captured with what to wake model. What to wake model embedding are very static. So a single word represented by a single embedding. Where it appear within the text, based on that, dynamically we change the embedding. That capacity don't have in what to wake model, right?
Yeah.
So this led us to the birth of large language model.
So basically, dynamically changes.
That dynamically changes. I mean,
Right.
when you provide the text to the model, looking at the text, where it actually appear, what are the surrounding words, it can change the embedding, it can generate the embedding dynamically. Okay, based on this context, the embedding should be something like that for the cat, because now apple, for apple, for example, now apple is, looking at the context, it appear that apple is used as a fruit here. Looking at the context, apple is used as a product, right? So that dynamic representation power is imposed by LLM, right? So the two main thing it introduced, one is positional embedding and another is attention mechanism. These two things actually change the world. Mainly this attention mechanism. Attention mechanism is that to identify the words present in the text that are related to each other. So this is a very powerful, uh, I mean, I mean, invention, you can say, right? For example, if you consider this sentence, the cat chased the mouse because it was hungry. Now, as a human being, you can easily understand what is this "eat" referred to, whether it cat or mouse, right? Who is this "it"? But how we can make the machine, I mean, understand that this "eat" is actually cat, it is not mouse. It referred to the cat, it is not mouse. So to do that, you have to consider all the other words related to this "it," and then you need to make a decision, right? So what is the relation between I mean, what is the distance between this the and it? What is the distance between this cat and it? Contextual distance, semantical distance, right? Then you can decide that or understand that, okay, uh, this it is actually referred to cat. Now, if you represent this it with a static embedding, always you got a similar, I mean, same kind of, all the words have some static embedding over there. Now, always you got similar kind of similarity between them. I mean, same similarity, same kind of day, right? So that means you need to decide what should be the representation of it dynamically by looking all the other words, and that is called attention mechanism. There are, I mean, beautiful mathematics behind that. We will learn in some courses in future, but in short, this is the attention mechanism. So within the text, when you present that text, it actually look all the other words and decide that relationship. Okay, which word is more related to which words, and based on that, it actually generate the next words or next decision. So this bring the real understanding of the text into the system, into the model, into the computer. So attention mechanism is very important invention in terms of LLM. And also this positional embedding, because position is also important, because dog bites man and man bites dogs. Words are same, right? Uh, but the based on the position of those words, the meaning become different, right? So it's also very important to understand which word appear in which position. So considering these two things, so position of the word and the relation with other words, it finally dynamically represent each word with its numerical form. So that is the main aspect of LLM. How in this way we actually finally got our intelligent system, super intelligent system that can able to understand a text fully, right? And the the model or the architecture behind this LLM is called transformer, right? So this transformer architecture has two parts. One is encoder and the decoder. Encoder, the uh, objective of encoder is to represent a sentence to its corresponding embedding by considering all these things. I mean, positional embedding, attention, right? And decoder is that it actually able to generate the next most likely word that actually can appear when we got this text. So if you start with a text, by looking at the text, looking at the words, what should be the next word that is most fitted after this sentence, after this text, right? So first you start with, I mean, when you provide a query to the LLM, your chat GPT start with that query. Looking at the tokens of the in the query, it actually generate the next word. Okay, what will be the next most probable words? Now, considering all of those words as an input, it generate the next words. In this way, it actually generate the whole text.
Just like we are having suggestions,
Sorry.
just like we are having suggestions while typing some mail in the like Gmail or any other mail.
Right, but it's, I mean, yeah, in the similar way. So you are writing something, based on your writing they are suggesting something to you,
Right.
right? uh, the similar kind of mechanism works here also. looking at your text, it actually generate the next most best probable word from the entire vocabulary. Then considering all of those texts, generate the next one. So in this way, it is actually generate the entire text. So that's why it is a generative model, text generation model, right? So I mean, all of you already aware of various application of LLM. You already, I guess, most of you or all of you are actually using LLM in different form. Uh, Obviously, we considering this kind of limitation also. So hallucination, sometimes LLM can generate something that maybe looks very realistic, but that does not holds, right? Because it is a probabilistic model. So it's thought that based on this text input, it should be the next best output, uh, right? So you can feel that okay, there is a very good answer, but it's not. It's not the correct answer. it it made it up by I mean itself. मैंने खुद से बना के दे दिया आपको. So something like that. Privacy is also an important concern over there. It also depend on training data, because on which data it has trained on, it can generate, or it can actually able to generate knowledge based on that information. So we need to use this model with some additional process also, so that with the query we can find out some I mean context also, and both, I mean we combining the query along with the context and pass it to the LLM, so it can look all the text, the query and the context, then it can able to generate the answer or the further text. So that is called RAG pipeline. So these additional things are need to be used to build a final uh, generative model. And also, I mean, sorry, these are some of the very common model current days. We are, I mean, we all know about this: GPT, Claude, Gemini, Llama, DeepSeek, Grok, right? Okay, I guess time is up. I mean,
Uh,
10
Sir, I
minutes
have
over.
one small question.
Yeah, sure.
Sir, is there any model that can read out doctor's prescription, because their handwriting is very unique, almost
I
many
mean,
different
yes, you
kinds.
can. I mean, not specifically doctor's handout. I mean, handwriting, but handwritten text. If you provide an image of handwritten text to Gemini, also,
Mm,
it's appear that it when working well. It suggests you. I mean, it extract the text also.
okay,
Now,
sir.
I mean, sometimes the handwriting is too worse that even LLM can understand that also. I mean, human being can understand that. I mean, that writing. So how can model? But if it is, I mean, rarely, I mean, readable, then these image to text kind of models are very well to extract the text, corresponding text. Okay.
Thank you so much,
Uh,
sir. Thank you so much.
Thank you. If you have any questions, you can ask, or I can conclude this session. Okay. I think this is a no question. The silence means okay. Thank you.
Thank you so much, sir.
Thank you. Bye.
Thank you so much, sir, for your wonderful session. I hope everyone is good with the concepts that sir has taught. So before wasting any more time, let's just start with our next session. Just give me a moment, and let me just introduce you to our next session, which is Behind the Magic, Transformers, Prompt Engineering, and LAN Chains. In this session, you will explore how transformers power LLMs and design effective prompts. So it will be given to you by Miss Rushil Sharma, and she is an associate data scientist at Tatras Data. Welcome, Rishal ma'am. Over to you.
Thank you, Rakshita. It happens a lot with me. People usually spell or pronounce my name wrong, so it's fine. Hi, everyone. Good morning. I hope you're having a good Sunday, learning a lot of new things.
Good morning, ma'am.
Good morning. Okay. I don't want to keep you as much because I know it's Sunday for everyone. Let me just quickly share the screen and then we can get started. Just a second. Okay. Can you tell me what you're seeing right now?
It just going a dive into transformers and LLMs.
And now? Same thing?
Yeah, as mentioned.
Okay.
Yes, now loading.
Okay. Okay, so let's start. Hello, everyone, and welcome to this session. I'm happy to have you all here as we dive into the world of AI together. Now, whether you have heard about ChatGPT on the news or you are just curious about the new technologies, this webinar is for you. We'll take things step by step, starting from the very basics. No prior experience in AI or data science is needed. I'll explain everything in simple terms. Now, here is our agenda for today. First, we will cover the foundations of AI, including what artificial intelligence is and how it can be used to create content. Now, this creative side is called generative AI. Then, we will introduce transformers and large language models, which is the cutting edge technology that powers AI tools like ChatGPT. Next, we will dive into prompt engineering, which is basically how to talk to these AI models in the right way to get useful responses. We will even do a hands on activity where you will practice crafting prompts and see how an AI might answer them. And after that, we will look at some cool applications of these models and discuss ethical considerations because it's important to use AI responsibly. And then finally, we will have time for your questions before wrapping up. Throughout the session, feel free to think of questions or comments. I will address them in our QA at the end. The goal is to keep things clear and engaging. So let's just dive in and get started with the foundations of AI and generative AI. By now, I know that you all might be aware of what Gen AI and artificial intelligence is, as I just joined the session few minutes earlier. But still, as I said, that I will like to keep it in very simple terms. So this is my version of this webinar. So, in simple terms, AI is technology that allows computers to do things we normally expect humans to do. Things like learning from experience, understanding information, spotting patterns, and making decisions. Now, good way to think about AI is it's software that doesn't just follow rules blindly, it learns. And we see it everywhere in our daily life, often even without noticing it. I'll give you a few examples like when your phone automatically unlocks because it recognizes your face. That's AI. When Google Maps warn you about traffic before you even hit the road, that's AI predicting patterns. When Spotify creates or YouTube creates a Discover Weekly playlist that mysteriously matches your music taste, that's AI learning from everything you listen to. And every time your voice assistant responds to Hey Siri or Okay Google, that's AI understanding language and acting on it. My phone just started with Hey Siri. Sorry. So even before Gen AI arrived, AI was already working quietly in the background, helping our devices feel smarter and more intuitive. Now, this foundation will set the stage for the next big leap that's called generative AI, which doesn't just analyze information; it creates new things. Now, over the past few years, a really exciting branch of AI has started to take the spotlight. That's called Gen AI. Now, Unlike traditional AI, which is great at analyzing data and making predictions like, is this email spam? Or what video should we recommend next? Gen AI actually creates something new. Think of it as AI with creative side. It can write stories, compose music, design images, and even generate realistic human voices or videos, everything from scratch. Now, how it works. Gen AI models, they learn by studying massive amounts of existing content like text, images, sounds, and they pick up on patterns, styles, and relationship. Then, once they've learned everything, when you give them a prompt, they use that knowledge to generate brand new content, which has never existed before. For example, I'll just keep it very relatable to everyone. Instagram famous trending nano banana model by Google can take a fun prompt like a panda riding a skateboard while eating a banana smoothie, and it instantly turns into a colorful image that looks like a digital artwork. Also, you see another image here which went viral on Insta where people used to make their 3D models in unique fashion. And there are even tools like 11 Labs that can generate realistic human voices so they can narrate podcasts or videos with natural tone and expression. So, to keep it very short, Gen AI is AI that creates. It does not just understands data, it imagines with new possibilities. And that is what is driving this new wave of creativity we are seeing in marketing, entertainment, education, and beyond, even on social media. Now, let's look at the difference between AI and Gen AI through something we all relate to, that is social media. Think about how traditional AI already powers your everyday social media experience. When you upload a photo on Instagram, it automatically recognizes faces so you can tag your friends. That's AI at work. When YouTube recommends your next video or Insta guesses the kind of content you enjoy, that is also AI, which is analyzing patterns, learning from your behavior, and predicting what you might want to see next. Now imagine you are creating a post and say, write a fun caption for my beach photo, and in seconds the system replies, sandy toes, salty hair, living life without a care. Now that is generative AI. It's not pulling that line from a database or predicting your next action. It's creating something new based on patterns it learned from millions of examples. Or or think about AI filters that can turn your simple selfie into a comic style portrait or place you in a completely different world, like a neon lit cyber city or a Van Gogh painting. That's Gen AI. And now we are all seeing multiple posts with type comment or comment something to get the prompt so that you can transform your image completely. Like there were women with multiple sarees and all of that thing, if that's relatable to you. I'll also give you another example. Now, traditional AI helps social media analyze and predict. It decides what content to show, detect spam, hate speech, or even personalize your feed. For example, if somebody is writing hate speech in the comments, it automatically identifies. The Instagram automatically identifies and will give you an option to hide it. Now, Gen AI will help it create and imagine. It will write your caption, design your thumbnail, and even generate videos or avatars that are being very popular now that look and sound like you. As MIT researchers put it, that Gen AI doesn't just make predictions, it creates new data that resembles what it has learned. So if traditional AI is like social media manager who knows what's trending and what should we see, Gen AI is creating content. It's like a creative content team which will write posts, design visuals, or produce fresh ideas every second. So in short, AI helps machine understand the world. Gen AI helps them create one. Now, next, what we will do is we will dive into the breakthrough technology that makes this creativity possible. That's called transformers and large language models. Let's look at this technology that makes these smart Gen AI systems possible. Transformers and LLMs. I know that you've just gone through with the webinar that Jayabrata sir gave you. It was a really nice explanation. I don't know if I can put up with that, but I'll do my bit. I'll try to explain and keep it very simple so that you all can understand. Now that we know what AI can do, Let's talk about how it works behind the scene. The key technology that drives many of today's AI breakthroughs is called a transformer. Now, what is a transformer? It's kind of a neural network architecture. Think of it like a special kind of computer program that is really good at processing sequential data, in particular, language. So, it was first introduced in the famous paper of Attention is All You Need, and I suggest you all to read it in 2017, and that has revolutionized AI. Now, what makes this transformer so special? Think of it like most older AI models, they read a sentence the way we read a book, one word at a time in order from left to right. But transformers don't read like that. They look at all the words in a sentence at the same time. It's almost like, taking a bird's eye view of the entire sentence instead of reading it word by word. And to understand how the words connect, it uses something called as attention mechanism. So attention is basically the model will ask itself which words matter the most in the sentence and how do they affect each other. Now let's take a simple sentence. The cat sat on the mat. So the transformer will doesn't just read it word by word. It can instantly connect cat with sat, cat with mat, and then sat with mat. Even though these words are not right next to each other, the model will understand that they belong to each other. This look at everything at once approach, this helps transformers understand the full meaning of a sentence, not just individual words. So, in simple terms, transformers understand how all the words in a sentence relate to each other, while older models only understood one word at a time. So, to put it in very simple terms, transformers understand the interplay of words in a sentence, they capture context, unlike older models that used to handle words one by one and one at a time. Now, this is just for visuals, and this is a basic structure of how transformer looks like under the hood. This simple looking structure is behind the massive brain of the popular models like GPT, Gemini, etc. that you use today. Image is just for visual purpose, and we will not discuss this architecture in detail as it's a beginner friendly session. Now, why do these transformers matter? Because many of the powerful AI tools you have heard of are built using transformers. In particular, large language models, or you also know them as LLMs, like GPT-3, 4, Claude, and others. They are all based on transformer architecture. So LLM is basically a transformer model that has been trained on huge amount of text data, often many billions of words from books, websites, articles. Think of an LLM as a mega combo of grammar, facts, and writing style all rolled into one giant program, sorry. And when you give it a prompt, for example, some input text that you all do, it uses what it has learned about language to generate human like text as output. A very quick example is OpenAI's model GPT. So, GPT actually stands for Generative Pre trained Transformer. GPT-3, 4, 4 Mini, 4.1, they all were pre-trained on massive internet text and learned patterns of how language is used. Then they can generate almost anything. They can even continue writing a story from a few sentences, answer questions, or even write a computer code for you. For instance, Google's BERT and OpenAI's GPT-3, 4, all based on transformers, can be used to generate text, help with coding tasks, translate between languages, and answer questions on almost any topic. This is why transformer based LLMs are considered state of the art in language AI today. I know that you have gone through all of these things in detail. I'm just giving an overview. Let's bullet point some of the things transformer LLMs can do. These are the kind of applications that we will touch on later, like, for example, creating content across media, now beyond text, variations of transformer models. They can generate images. Sometimes we call them vision transformers or combined with diffusion models or even audio. For instance, there are AI models that can turn text description into an image, just like we referred to Nano Banana Gemini, so or convert text into a human like voice. Writing code. Now, some LLMs can write or even complete computer code. For example, AI tools like GitHub Copilot, they help programmers assist them by suggesting code, and research systems can write software or analyze data. Next up being answering questions and explaining. So you ask them facts like what is the capital of France, or explanations like how does photosynthesis work, and they respond in natural language. Lastly, understanding and generating text. They can chat in a conversation, write emails or essays, translate languages, and even summarize the information. All these abilities come from one core idea. The transformers lets the model see context effectively, and training on vast data lets it store knowledge about language and the world. Now, one specific AI that many of you might have probably heard or even used is ChatGPT. Now, GPT uses a family of GPT models, GPT 3.5, 4, now the 5 has also come, to generate conversational text. So you type a message to it, it replies as if it's having a chat with you. It can answer questions, write stories, explain topics, and much more that we all discussed. Now, all because it's a transformer LLM trained on tons of text. ChatGPT and other AI assistants show how versatile these models are. So, in summary, again to put it in very simple terms, transformers are small architecture behind modern AI language models, and LLMs are huge transformer based models trained on lots of text. They are what allows AI to handle language so well. So even if you write anything, because everybody usually conversates in a different tone, in a different way, or maybe you want it to reply in a certain way. If you have ever tried the voice assistant in Chat GPT, you will see how well it performs and how well it conversates with you. Okay. Next up, we will see how to interact with all of these models effectively using prompt engineering. Now, prompt engineering is very, very important. So far that we've seen that advanced AI models can do amazing things. They have the capability, but if you don't know how to ask for that output, that capability is going in vain. So how do we get them to do what we want? That is where prompt engineering comes in. It's the art and science of crafting the text that is called the prompt that you give to an AI in order to get the best possible response. According to a general definition, prompt engineering is a process of structuring and crafting an instruction in order to produce the best possible output from a Gen AI model. In other words, it's how we ask the question or how to make a request to the AI to get you exactly what you want. Now, what exactly is a prompt? It's just some text you give to the model describing the task. It could be a question, it could be a command, a scenario, or even few examples. For example, if you want help writing a cover letter, your prompt might be write a professional cover letter for a software engineer applying for a tech startup. I know you all might do it. For a text to image model, a prompt can be a watercolor painting of a sunset over mountains, etc. So, but there are key principles of good prompt engineering which you need to learn that include making your request clear, specific, and providing enough context. Now, effective prompts are the prompts that are clear, concise, and they provide sufficient context to elicit the desired response. I'll give you very practical tips. Always be specified and detailed. Tell the AI exactly what you want. Instead of just saying, tell me about physics laws, you might say, explain Newton's law in simple words. You can also specify things like tone or style, which can help, like write it like a news article or explain it to a 10-year-old. That's being specific and detailed. Now, setting up role or persona, you can prepend your prompt with something like you are a science teacher or you are a physicist. This gives the model context about how to answer. For example, you are a travel guide. Describe the top attractions in India or internationally wherever you want to visit. Now, this will make the AI respond as if it is an experienced tour guide. That is about setting a role or persona. Then we provide examples or format. You will need a specific format, like if you need a specific format, for example, like a list, a table, or bullet points, you have to mention it. You can start with an example interaction or simply say, list the steps or use bullet points. That is about providing examples of format. Then comes ask for reasoning or steps if needed. If you want the model to show its work, you can ask it to think through steps. For example, explain your reasoning step by step so that you can get a clear vision of if it gave me this answer, what was the reason behind it. Okay, and lastly, iterate and refine. If the first answer isn't quite what you want, because everybody has a different expectation from the response, you can try and refine your prompt, because sometimes even very small changes in phrasing or even adding details can make a lot of difference in your response that you get. Okay.
Excuse me,
Now,
ma'am.
mhm.
Ma'am, can you just help me? What kind of prompt should we give so that it can explain me statistics?
We will do that in the hands-on. So once we do that, you'll get to know. Okay.
Okay, ma'am.
Okay. Okay, now that you've seen what GenAI can do, let's talk about how we communicate with it. That's where prompt engineering comes in. Think of a prompt as the way you talk to the AI. It's your question or instruction, but the quality of your prompt directly affects the quality of the answer you get, that we just learned above, right? Let's look at an example like, um, if I simply ask explain how AI works, the model might give me a very long, generic answer full of technical terms, and honestly, most of us would zone out after the first line. But if I give more specific prompt like, you are a YouTuber making a 1 minute explainer video for beginners, explain how AI works using a simple example from Instagram recommendations. Now, the AI knows who it's speaking as, who it is speaking to, and how to frame the answer. And the result that you will get is a clear, structured, and easy to understand explanation, something that actually connects with the audience. Now, that is the power of prompt engineering, and you will not learn how to write perfect prompts in one go. It's actually a job, and it can take like months and weeks to actually get the right prompt, because as I said, a minor tweaking in the prompt can result into a different response. So that is the power of prompt engineering. It is not just asking questions, it's about guiding the AI to give you the right kind of answer that you want. So, in short, a vague prompt will give you a vague result. A thoughtful prompt will give you a powerful one. So it's really about communication. As AI, think of AI as a super smart but literal assistant. The clearer and more detailed your instructions would be, the more useful the response will be. For beginners, it helps to experiment. So I would want you all to try a question, see what answers come back, and then try tweaking your words. You will quickly learn what works best. Try it today. Okay? Now let's do a hands-on activity of crafting prompts. Let's put engineering into practice with a quick activity. Um, Here's a scenario. Let me stop sharing and share again. In just a second, okay? Can you see my screen?
Yes, ma'am.
It's temporary chat, right?
Right, ma'am.
Okay. Okay. Now here's a scenario. Suppose you want the AI to help you plan a trip. First, try a very basic prompt like plan a trip to, let's see what we have written here. Plan a trip to Goa. Since it's Goa season, so now it has given you a 5 day Goa trip itinerary. Like day one, you will go here, Kalangrute can Condolim and the activities that you can do. And it has also given the recommendations of the food, right? And then day two, day three, day four, and day five. So it's a lot of information, and it has also given you suggestions on the basis of the budget it has assumed, right? It has given you,
Excuse me, ma'am.
yes.
Can I get this, these highlighters in the table? Then I can download this table in the Word format.
Y- I didn't get you,
For
Javed.
example, yes, ma'am. I want to, get these instructions in the Word form, in the table, in the form of rows and columns, like having serial number one, serial number two. Then we have
Yes,
the
you can ask
description.
it to do it. You can ask it to do it. It will give you. And you
Uh,
can ask it to give it in a word format. When I'll give you an activity to do it, after this, once I've done or completed this, you can try it on your own.
can I please show the one example so that I can see here?
Can
Uh,
I complete this first, Javed?
yes, thank you.
Okay. So, where was I? The prompt that we gave was plan a trip to Goa, and it has given this. Now let's try and be a little more specific. I'll just quickly copy this and paste it here. Now, as per what we've learned, we have given the context. You are an experienced travel planner. I have also given the days, and I have also given with whom I want to visit. It's for a family with kids, including one museum visit, one outdoor activity, and one local food experience. I have also specified the budget so that it can cut through all the nonsense that it is given about the multiple budget stays, and it is already assumed, right? So it will also keep in mind that I have a family of 3 people. Now let's see the response. So it's planning trip with the budget in mind as we have given it the context. Okay, here comes the quick trip summary. Duration 3 days, 2 nights. Base area North Goa. Again, this is assumption. If you want to plan for South Goa, you have to tell him. So the highlights are museum, outdoor activity, and the local food experience, which we gave emphasis on or we set the context. Similarly, it has given a day to day itinerary, which is much more detailed and much more cleaner. So, as you can see here, it has also given estimated budget, which is clear and conservative estimates. The target would be 50,000. The accommodation 2 nights estimate is 8,000. Sources are also listed here. Airport taxis. So everything is given in detail, right? Now I think somebody said, um, here you got this as a table format: morning, afternoon, evening, and night. And then you can copy it and directly paste it to any of the Google Sheets, Javed. Is that helpful?
Thank you, ma'am.
Okay. Okay, so we have seen how if we set the context right, like we just studied here, we be specific, we use the roles, we define the output, and we can even request the reasoning. Now, there is another quick example that I would want you all to try. For example, if I just write an essay about healthy eating, the output may be okay, but not very specific. Instead, I might say, now refer to the steps we learned before, and I want you all to try refer to the steps that we learned before, and then try tweaking the prompt to make it more refined, detailed, and cohesive. For example, I could ask, I'm just giving you a hint. Imagine you are a nutritionist explaining healthy eating to a teenager. Write a 5 sentence paragraph using simple language and an example of a healthy snack. Now, in here, the example that I just gave you, the improved prompt will set a persona, which is nutritionist, audience, that is teenager, length, that is 5 sentences, tone, which is simple, and even the format, example of a snack, right? Now, the AI's answer will likely match these instructions much better. I want you all to pick a topic today. It can be anything that you like. Just go ahead and try playing with these prompts, because you will learn about AI, you will learn about Gen AI. You know everything that's out there, but until unless you don't know how to guide the AI to get you the response, all of the learnings will not make any sense. Okay, so that's a very important activity that I would highly recommend all of you to do it. Okay, moving on to the applications and ethical. One second, I just share it again. Can you see my screen? It's a slideshow.
Yes, ma'am.
Okay. Now we have talked about how these models work and how they interact with them. I'll just step back and we'll go through the applications of GenAI, which are transformer-based LLMs that are which are used in many real-world applications across industries like content creation. Nowadays, everybody uses GenAI to make their content. For example, ask for suggestions about scripting or even plan the content calendar for them. So it can draft written content like articles, social media post, or even marketing, right? So if you are a content creator out here, you can ask ChatGPT to create content plan for you. It will do it. Again, the prompt engineering is very necessary, because you will have to ask GPT or whatever model you use to respond in a way that you want audience to see. Okay. Secondly, customer service and chatbots. Many companies now use AI chatbots to answer customer questions or provide support. These bots can handle simple inquiries or even guide customers through processes by generating human like responses, like Swiggy, for example, Zomato, even Airtel application that I just used, so I remembered. Coding and software development. AI assistants like GitHub Copilot use transformer models to suggest code snippets as you type. Now, researchers are also using AI to write code, debug errors, or even generate entire programs. Then comes the education and learning. AI tutors can answer questions on topics, explain concepts in plain language, or even generate practice problems. For example, if you're learning through a course on Coursera or Udemy, somewhere you can ask questions to the chatbot there, which is an AI powered chatbot, and it will answer as per the course that you're going through. So that is where it is helping in education and learning. Then comes the business and productivity. Teams use AI to summarize documents. Even I use it. For example, there's a client call that I have to be in. I record that call using Fathom, which is free. And then I don't have to handle the hassle of creating minutes of the meeting, or I can even ask from that application that what was the action items that I had to do. So it saves tons of time. Again, you have to know how to generate a response. For example, an employee might ask the AI to summarize a long report or translate an email into another language, right? In health and science, GenAI can help design new molecules for medicines or materials by suggesting chemical structures. So medical AI, not LLM specifically, they can help analyze images or even patient data. Entertainment, we all are seeing nowadays. Creatives use AI for storytelling, game design, or even music composition. So, all of these are the applications of LLMs. These examples we show that how the transformer based AI is a flexible tool if it involves language, code, or even media, right? Now comes the most important piece that I want to share with you all. With all this power comes responsibility. Generative AI will raise important ethical questions like accuracy and hallucination. Now, what is it? LLMs generate content that sounds plausible, but they don't actually know facts. Sometimes they make things up, phenomena often called as hallucination. So, since it's generative AI, if you ask a question, it has to generate something, right? Whether it's factual, whether it's correct, that does not matter. It has to create something, and they are not factual. So when they simply make things up on their own, that phenomena is called hallucination. For example, AI might confidently generate a fake quote or statistic. That is why it is very critical to double check any important information the AI gives you, right? um, you see here at the bottom, ChatGPT can make mistakes. So they write it in a very small font. People usually tend to ignore this, but this is very, very important. Then comes the bias and fairness. Now, as we discussed that these models learn from data collected from internet, books, which can contain biases, right? As a result, AI might sometimes produce output that is biased or offensive. So it is important to critically evaluate AI generated content and be aware that it can be potentially biased, okay, because that's there in the training data. Then comes the deepfakes and misinformation, which is very common these days. I am sure you might have seen those videos or even images. Gen AI can create convincing fake media. For example, it can generate a realistic looking image of someone who doesn't even exist, or it can mimic a person's voice. Studies even warn that, ability to produce convincing deepfakes and synthetic media, they threaten the foundation of trust, truth, and democratic values. This means that people could misuse AI to spread false information or even impersonate others. We have to stay alert. I don't know if you all relate to this, but on social media nowadays, there are many, many videos that are circulating which are AI generated. And now, if a person is actually doing something good, people will always type a comment, this is AI, right? So, this is where we are right now, and we have to be very, very considerate when we ask AI to generate something for you. Then comes the privacy and data security. Now, some AI systems use user data to improve. We should be careful with the sensitive or personal information. For example, always check with the privacy policies that we just scroll and simply tick mark. Now, you should always read it and avoid sharing confidential data with public AI tools like your name, your address, your account numbers, for example. Don't share it. So, in short, while AI tools like LLMs can be incredibly powerful and useful, they are not perfect and they carry risks. So, the AI community and society at large, they are actively discussing, how to manage these risks because it's not in our control. Because people are they are very imaginative out there. They can ask Gen AI to produce anything that even you can't imagine, right? So, as AI users, we can do our part by using it thoughtfully, verifying facts, respecting privacy, and even treating AI outputs as helpful suggestions rather than unquestionable truth. So, I'll just quickly wrap up and give you the recap of our session. We covered AI basics. We learned that AI enables machine to perform tasks like learning and problem solving. We went through transformers and LLMs. We learned how prompt engineering works. If you want, I can share this PPT also with you all. Then we did some hands on. We saw how changing the prompt can actually, you can visibly see a difference. But nowadays, it's been so refined that even if you throw a sentence out there, it will structurize and it will give you a response. So prompt engineering is becoming tough. And then we saw some applications, and then lastly, we saw how we should use AI with ethics. We should use AI more responsibly. We should watch out for biases, verify facts, and remember there is a realistic fake media out there. So AI is a tool, and like any tool, it requires judgment and ethics from the user. So thank you all for participating. I hope this webinar has given you a clearer picture of how transformers and LLMs work. I know that you have learned about this in the previous session also, and these technologies are evolving fast. So just keep exploring and learning and make sure we use AI ethically. So that was it for the session. Anybody wants to ask?
Hello.
Yes, Thira.
Yes, ma'am. Myself, Dheeraj. So, I'm just a PhD student. So, while writing paper, when I just write a line, okay, so I have to find from which paper it is taken. Let's say I'm writing like Newton's third law. Okay, so I want to ask AI just from where it is taken. Okay, because I don't know when I'm writing
Correct.
paper, I'm writing a
So-
line. I don't know
yes.
it's perfectly mine. Okay, it may be researched by someone, so I want to give reference. But when I sought for a reference using ChatGPT, the reference they got is non-existence.
Correct. I understand. So that is where, multiple models come in. I would advise you to use Perplexity and not ChatGPT in that case. Perplexity has a research mode which is actually being used by the PhD people. And if you use Perplexity, it will give you proper sources from where this citation, you're talking about citations, right? Where this
Yes, ma'am.
resources and citations have been taken. So they are legit. When I also write a paper, I use Perplexity. So I would highly recommend you to use Perplexity because even in ChatGPT, it will give you some resources that are not even existent.
Yes, yes.
It will take you to a website that doesn't even exist. So you can use Gemini, Claude, and my personal favorite is Perplexity.
Okay, thank you, ma'am.
Okay. Okay, guys. Thank you all for joining the webinar.
Rushil, there are questions in chat. Have we covered those questions?
I didn't see that, ma'am. One second. Gaurav, we just went through how to improve prompt in the slide deck. If you want, I can share that slide deck with you. Another thing, which tool should I suggest for best prompt? One thing that I do is give the context. If you have a story in your mind, just write that story down. Go to Google Gemini and ask Gemini to give you a detailed prompt for ChatGPT or any model that you're using. For example, Perplexity. Ask Google Gemini because the context length of Gemini is longer as compared to others. When I say context length, चाहे आप जितनी लंबी स्टोरी लिखना चाहते हो उस पर आप लिख सकते हो. फॉर एग्जाम्पल चैट जीपीटी एंड अदर मॉडल्स दे हैव a fixed context length. Gemini's length is very long. So write a story and ask Gemini to give you a detailed prompt for ChatGPT or any other model that you want. Once you get that prompt and try pasting it, you will get better results. But in order to understand that prompt, you should also learn how to do prompt engineering because we say that, right? If you don't know what the answer would be, no matter if you have the answer in front of you, you will not understand it. So you should have the knowledge of how prompt engineering works in order to actually identify this is a good prompt. Okay? I only see this question, ma'am.
Okay, and another one by Kushangra we have already uh,
Hanji,
answered.
ma'am. Yes.
Okay, ठीक है.
Okay, ma'am. Okay,
Okay.
guys. Thank you everyone for
Thank you
joining.
so much. Thank you,
Thank you so
Rushil,
much,
for
Rushil.
such a wonderful session. And it
Have a
was obvious, it was not that much repetition for them, Rushil. So previous session was based on NLP. Even Sarab sir also covered NLP thing. And it was very good session. Thank you, Rushil.
thank you.
Thank you
Thank
so
you.
much, Rushil.
Thank you everyone. Enjoy your Sunday now. Oh, no, they have another session, right?
Yes.
Two more
Okay.
sessions are
Bye, guys. Have a good day.
Bye, Rochelle. Bye. So I hope now everyone was happy with the session and you have learned a lot more things. Now let's just have a lunch break for you all, and it will be from 12 p.m. to 1 p.m. And after that, you bring back your energy, and at 1 p.m. we will be having another session. Is there anything, ma'am, that you want to mention here?
No, no, Rakshita, thank you. So I think we have two more sessions, and we have already covered the doubt sessions. There were few questions in the chat about the assessments. So assessments, there are two things. One is the aptitude test. Aptitude test we have already told you. It is for the for making the spot in the internship. So it will be tentatively on 30th of November. And today's assessment session that we have written is wrap up and assessment. That is the just to give you the exposure how to use the Educ Lab, because we will be posting some uploading some assessments on Educ Lab. We recommend you to just attempt those assessments. These assessments are not mandatory, but we recommend you to attempt those assessments, because this is how you will be attempting your aptitude test also. Okay, so that's it from my end, Rakshita, I think. So, Ankit, I would like you to unmute and please ask your question, because everybody is writing mock test, mock test. What do you call as a mock test? Because we were just sharing two things when we are saying ki we having an aptitude test for those who wants to make spot in the internship. Aptitude test ka sample we will be sharing over email. This is one thing. Second is today in the evening or in the late afternoon, we will be sharing the assessments with you. Assessments will cover questions from the sessions that you are having from last 2 days. So this is just for the learning purpose. So now what is this mock test? I don't understand what you are specifically asking, Ankita, if you please unmute and ask. So Gaurav, we will be sharing the details with you. We will be sharing the details with you. We are going for the break now. We will resume at 1 p.m. You will be having another two sessions, and we will let you know how to attempt the assessments. Assessments, again, I am saying, are only for that. There are two things: assessment and aptitude. देयर इज नो एप्टीट्यूड टुडे. एप्टीट्यूड ऐसे नहीं हो सकता ना एकदम से आज ही सेशंस दिए और आज ही आपका एप्टीट्यूड हो गया. एप्टीट्यूड टेस्ट इज one of the criteria to get enrollment in the internship. It will be on 30th of November, but this is the tentative date. Again, I am saying tentative date. Today we will be sharing only the assessments. Assessments will be based on MCQs. So this is just for the learning purpose. So that's it from my end, Rakshita. So I think we will again meet at 2 p.m. Sorry, 1 p.m., right?
Yes, ma'am. We will be
Ma'am,
meeting
thank
again
you.
at 1 p.m. and
मैम आई हैव अ क्वेश्चन.
Yes, yes, Ankita, please.
वो जो एप्टीट्यूड टेस्ट होना है 30th को, उसके लिए आर यू गोइंग टू प्रोवाइड एनी काइंड ऑफ सैंपल क्वेश्चंस और एनीथिंग एल्स?
Exactly the same thing I am repeating. Yes, yes, we will provide sample aptitude test, but over your registered email. जो
ओके
आपने रजिस्टर हमें ईमेल दिया है, वी विल बी प्रोवाइडिंग फॉर श्योर. ठीक है. और एग्जैक्ट डेट, अगर कोई डेट एक्सटेंड होता है, अगेन वी विल लेट यू नो. इफ इट इज ऑन 30th, अगेन वी विल let you know, but it will be for duration of 1 hour, and you don't have choice to attempt it any time of the day. You have to be present during that 1 hour only, right? Have I answered your question, Ankita?
यस मैम, थैंक यू सो मच.
Thank you. Assessment and
Sorry for
Zen. So Zen
sorry for interrupt,
dashboard
मैम.
में. हम्म.
मैम एक्चुअली जो मेरा डैशबोर्ड है, इट्स शोइंग नो डेटा फाउंड इन माय एजुकोलैब डैशबोर्ड.
So you need to subscribe The
No, ma'am,
workshop
actually,
that we
he is mentioning that assessment abhi khali hai. There is no assessment uploaded for you right now. Once we will upload, we will inform you all. Don't need to worry about that. And we will also give you a walkthrough again. We have given it in the morning at 8:30 a.m. But again, we will be giving it. Don't need to worry about the same. अभी आपको कोई assessment नहीं मिलेगा. Right now, you have only received the recordings of your yesterday's session. So don't worry about the assessment. आपको सारे assessment मिल जाएंगे.
Okay, thank you, ma'am.
Sure.
thank you everyone. So let's meet at 1 p.m.
Yes, sure. Thank you so much, everyone. Hello, everyone. I hope you all are doing well. Let's just start within a minute till our mentor joins. I hope I'm audible to you all. If
Yes,
any...
Rakshit.
Okay, thank you so much for confirming. So let's just start with our next session, which is on... Okay. So let's just start with our next session, which is on agentic AI, building autonomous goal-driven systems. In this session, you will explore how modern AI systems evolve from static prompt to autonomous agents. And this session will be taught to you all by Mr. Partha Sarthi Mukherjee, who is a lead data scientist at Tatras Data. Over to you, sir.
Thank you. Thank you for this nice introduction. It's always a pleasure to join this kind of workshops and share my understanding and ideas with interested people on of this server. So we are all on time. So without much ado, I will start sharing my screen. Please let me know if you can see my screen. Just give me a moment. Okay. So, yeah, I hope you can see my screen, right?
Yes, sir.
Okay. Uh, all right. So I will present. Right. Okay. So it's visible, right? I mean, this first slide is okay.
Yes,
Right.
sir.
Okay, so you already know, what is the topic that we are going to discuss. I have changed the title a little in the first slide, right? Instead of saying, you know, uh, just a guide to implementation and how it is different and all that regular stuff, I have written this is a frontier, right? I mean, and you know the meaning of frontier, right? I am trying to bring a flavor of battle in this discussion. Now, uh, you all know that AI nowadays have reached certain points and it is showing certain behaviors which is not even explainable by the human, right? Which is very critical to kind of comprehend and explain how exactly AI is working in some of the cases. This has not happened before, right? Even when the atomic bomb was created, it's a bad example anyway, but what I want to infer here is very applicable here. So when this nuclear fission has been created, people could compute that what would be the energy released if certain grams of nuclear materials are passed through that process. It was exactly predicted. There was a something deterministic about it. So people knew that if I, use this equation, if I use this material, if I do the experiment for this time, then this will happen. So people knew about it. It's a very bad thing that people use it in a evil cause, but people knew about that technology. But this time, we are standing really in a frontier which we do not understand very much, right? Even being a lead data scientist, I'm telling you that not every part of this AI is very well explained by the human. So human have designed this program. They are possibly you have known this far. There is a heavy amount of probabilistic reasoning involved in this process. And what happened is that the way this thing is developed, we are not able to predict exactly how this model will behave, right? So whenever we are making agents and LLM-based systems like this, we have to be very careful about what we are designing, right? Because you perhaps all know that this new AI system is going to create a drastic change in the business model landscape. The way analytics, used to be done, the way business computation or scientific computations used to be done, all things are changing. Already it has changed. Already it has changed. You know that in a lot of different applications that you see every day, you can see the effect of AI. So that is changing. So no one can stop that technological change. But at the same time, a lot of ethical dilemmas and responsibility concerns are coming. So that is why it's almost like a battleground where being an AI enthusiast or an AI engineer or even a person who is just using the AI, people should understand how these systems behave and what is the best way of using it so that it does not confront our own existence, right? Now you see that I am giving you two stats here that agentic AI will autonomously resolve 80% of the common customer service issues without human intervention by 2029. So we are telling about how significant this technology is. Second, 50% of all service requests will be initiated by machine customers powered by agentic AI systems by 2030. So these two are two big jumps, right? Possibly, when computer first came in our life, things were like this, right? But acceptability of the computer and the growth of computer-based technologies took nearly 20 years or more, right? But this is happening too fast now. This is happening within a scale in less than 10 years. That is happening. So things are changing very fast. So it's very important that we learn the core technology. We understand how these things work so that we can better use this using a good cause. Moving on, I will try to define what exactly is an agentic AI. And I'm kind of assuming that you have already seen some artificial intelligence applications using different mathematical models in the past, sessions in the workshop. So let's talk about agentic AI. So what I'm saying, I am just, an IBM definition I have broken down into a few points and I have highlighted, some terms here so that we can better understand the system. So first of all, it's an artificial intelligence system that can accomplish a specific goal with limited supervision. A very important term. By limited supervision means this is where, it differs from traditional AI systems, right? So already that you have seen in the previous sessions maybe that whenever you are trying to train develop an AI model, you need certain amounts of training. So this training, I mean, the machine is nothing without this training data. It cannot learn anything if human does not give a training data if human does not curate the training data. And only exposing the training data is not sufficient. You have seen that there are reasons that even if you have a training data, the model can overfit or underfit. So human knows what is the best way to present the training data to it so that the model can perform to certain degree of accuracy. So there was supervision limited. But here we are first time seeing that something with very limited supervision, and that's great news for AI developers, right? That we don't need to supervise and spend a lot of time to create a model. So that's a great thing. The second and a very important thing is it consists of AI agents, right? What is an AI agent? Basically, they are machine learning models that mimic human decision making to solve the problems. So you see that the first three terms that I have highlighted, one is limited supervision, second is AI agent, and the third one is human decision making. So you see that slowly we are creating a system which will require less human effort to adapt and to start behaving the way human did. A very interesting part of human cognitive skills was that decision making, right? Uh, our technology landscape is 5,000 years old. And we have reached here as a species by making interesting decisions. I cannot always say good decisions, but interesting decisions, which separated us from other species as well. So it is mimicking that extraordinary capability that a human has nowadays, that decision making skills. And now we are having something that needs less supervision as well. In the last paragraph, I am trying to say that how actually it is trying to achieve a goal. So in the first point I have said something about a goal. And in the last point, I'm trying to tell you how it is trying to achieve that goal. And you see, you can read it. So I am not reading it word by word, but you see that what it is trying to do is basically break up a big problem into small subtasks, right? And then it is trying to give an answer to the problem. This is the very fundamental paradigm of how human used to solve the problem, right? How human used to solve very big problem. So one of the greatest achievement of human was sending a rocket to the moon, or sending a spacecraft in space. How human did this? It did not happen by everybody came in a room and they started building a spacecraft. It did not happen in that way. A group of people solved the problems of physics. Based on those solutions, another group of people solved the engineering of aerodynamics. Then the engineering came to the manufacturing process, where based on different millions of factors, people carefully handcrafted all these things. Finally, everything was put together and tested many times. Many failures happened, but we got something. So this is how something is orchestrated, right? Laws of physics in board, designs in engineering, manufacturing in the plant, different tasks with different unique goals have been orchestrated to achieve something very big. So this is also doing something very similar. It is trying to break down a problem into some subtask, and based on those subtasks, it is trying to execute them through something called AI orchestration. Now, AI orchestration is a very heavy term, right? But we can simply understand this by comparing this to the analogy I just gave, right? So this is how we can kind of sum up what is an agentic AI, right? I would really like you to kind of read this slide very carefully and try to understand how we are defining the scope of agentic AI. I would, not wait for the end of the session to have the questions, right? You can immediately start asking me the questions. But I would, request you to kind of unmute and ask questions directly rather than, writing them in chat. Okay. So any questions so far, whatever I have said? Oh, questions and questions. Good. So let's move on. Okay. So next, we will even try to break down this into a little more technical way, right? Sorry. So what we will do is that in an agentic AI, this is what is a sequence of work that the agentic AI is doing. First, it is doing perception. Second, it is doing reasoning. Third, it is doing some planning. Then it is taking some action. And finally, it is learning. You can, understand, right? Now, perception means you are trying to sense in which context you are working, right? Say I'm giving a simple problem. Say I'm saying that let's take a simple business application. So I'm saying that I'm asking an agentic AI system that compare the revenue of IBM over the past 5 years. Say I am saying this is a problem. It's a simple problem, right? So first of all, in the perception stage, it understands that to answer the question, what kind of data I need to collect. Naturally, one data is, IBM's revenue report. The other data is to, kind of make sure that the revenue reports are in the range. But mostly, it should focus on IBM revenue reports. It may decide, it may need to kind of figure out that from where I will get the revenue reports. Will it be the IBM site itself or some open source search or whatever it is? So the first thing is to understand that what would be my source of knowledge, just like we do. Second is the reasoning. Now, maybe reasoning is not exactly a very accurate word here, but this is exactly what it is used in the theory. So reasoning does this. Reasoning tells the AI to understand the problem and prepare itself for the plan. So based on the question and the data that we have gathered, it try to understand what needs to be done. So by and large, with this question, we need to learn what we understood is that, well, somehow I need to find out the numerical data for revenue for IBM. Then I need to compare them. And now, we need to, show some graph or something at the end. So reasoning basically tells, generally what should be done, with a particular question and the associated data. The next step is planning. And this is a very important step. The accuracy of the system, depends a lot on this planning. So what can happen in the planning? If I take this particular question, compare the revenue performance of IBM over the past 5 years, we can break down the problem into some parts. First of all, first step is what is last 5 years? What is the past 5 years? So this year is 2025. So I am looking for 2025, 2024, 2023, 2022, and 2021. The second part of the problem is that retrieve IBM revenue of 2021, retrieve IBM revenue of 2022, and so on, and retrieve IBM revenue of 2025. Now, This is, planning. Then it has to compare it. So it knows that by comparison means whether the revenue is growing or the revenue is falling or the revenue is oscillating between some values and do stuff like that. And the final step of the planning will be, well, now if you have a comparison, you should draw a graph or produce a table, telling or explaining the results and maybe writing a comment. So you see, the planning is a very important thing. So for this particular problem, the planning is something like this. If the problem is something different, for example, how to assemble a computer or how to assemble a PC, the planning steps will be very different for that. But in general, if you have understood this, you can now see how we are trying to break down a problem into small subtasks. Okay? This is what planning is all about. Next comes action. So it is, I would say, an easier work. If the planning is accurate, then we can actually execute it step by step. For example, retrieve the IBM revenue of 2021. If this is a step in the plan, then we can use this step to find the revenue in a in a numerical form using the Google search or some retrieval system or something. So how this retrieval system works, I'm not going there, but I mean, for now, take it for granted that there are very powerful retrieval systems also in place that are used to feed the data to the AI whenever is necessary based on some query. And based on these actions, I will talk about these actions a little more later, but based on the action, we will do this step by step, and finally we will produce some result. In action also, we need to do some replanning. For example, if we don't get something done, I mean, if we don't find some information, then what else should be done? Right? Suppose the AI have identified that I cannot get the data from 2022 to 2024. For the rest of the year, I'm getting the data. But from 2022 to 2024, I am not getting the data. So what it can do? Maybe it will decide that, well, let's see that if someone is talking about the revenue comparison within this period. So instead of getting the exact values, it may try to find out that what happened between this period, right? Or maybe try to find out a reason that why it is not getting the data. So see, the action itself here may involve some step that we can define as replan, where some decision making can take place. Remember the word decision making that I mentioned in the previous slide. Once that is done, in this learn step is actually not the next step. It's something that happens continuously as a part of the orchestration. In learn, the AI learns from the mistakes. For example, it has produced an answer and user has given a feedback. Maybe you have seen this in ChatGPT. Based on this feedback, the LLM try to resolve the problem again and improve the answer. And that improvement can happen in any of the previous phases, like perception phase, like reasoning phase, and everything. So this is how the learning helps to achieve a better framework, a better model to do that. And the scariest part is this the AI orchestration can do on its own. So you have just started the wheel to roll, and it's almost like a downhill slope where the wheel is started rolling very fast. And the design is so beautiful that you just have to get the system going, and then the agentic system can improve itself a lot. You remember I said in the previous slide that less human supervision. Less supervision means less human supervision. So this is pretty much what is a working policy of an agentic AI, right? Any questions here? Any comments? It's not necessarily be a question. Any comments? All good? Do you find this reasonable?
Can we have yeses or nos in the chat? Or you can just raise your hand, or you can give the thumbs up.
All right, no problem. I mean, if there is no question, that means I'm doing a good job, possibly. Or these things are itself very interesting. Anyway, now
They
let's
are
have a.
writing in the chat also, sir.
Yeah, I'm trying to look at that also.
Right. Right.
Okay. All right. So comparing this with traditional AI, I mean, and I will not go through this again. This step by step. You can see what are them. Just have a quick snapshot at this agentic AI features and how it is different from traditional AI. This is not a point wise comparison, right? So it not necessarily that the first row of agentic AI and the first row of traditional AI are talking about the same thing. I'm just listing down the features of both of them in two different columns so that you can see what we have in traditional AI and what we do not have in agentic AI, right? um, mm, though for traditional AI, it is written that not suitable for complex tasks, but you can guess that the complex word itself is a little ambiguous, right? I mean, relative as well. So this is how we are different from traditional AI. So let's move on. Okay. Right. So let me show you an example that how an actual AI agent may work, right, in a particular use case. So you see that the first thing is that this is the user is asking a question. Look at the sky. Do you think it will rain tomorrow? If so, give the umbrella to me. A very simple question, but can be very crucial for some work. So this question is going to the perception, and the AI is percepting the situation. Means the AI is gathering the weather data, past and present, previous trends, maybe satellite images, whatever is necessary based on the significance or how crucial the problem is. It is collecting all of this stuff. Now, from this perception, it cannot straight away go for reasoning and finding the solution. It needs some learning. So this brain part, you can see that here we have two things called memory and knowledge, and then we have this decision making. So this decision making section is basically the place where the AI gets the capability of reasoning, right? Or planning. But this is not happens on its own. There is no magic here. It uses some memory and knowledge that has been inflicted or infused in it through past exercises and uses it to kind of do the decision making. So this is pretty standard in pattern recognition. It try to recall what it has done for similar type of problems in past, and based on that, it is trying to do that now or at present. So this is what is happening within the brain. It has been written as brain, but essentially it has two parts. One is the reasoning part, and the second is the memory and the knowledge part. Every reasoning or decision making that human do is also been driven by this approach. That is why a little kid, an infant or a child cannot always make a great decision because his or her brain does not have the capacity of that much memory or that much knowledge. So through experience, it learns and start making good decisions. Once we have this perception and all the inferences and ideas from the brain, it starts taking, actions. There are lots of things written here in the action. You don't need to worry about it. But this action actually gives, decides an action. So remember the term decision making. So this tries to give an action, and it also here is the interesting part. Say the human was asking, if so, give an umbrella to me. So what will happen? The AI will either give it an umbrella or not, right? But it's not only there. There would be something called reasoning or explanation. Not reasoning. Let's stick to the term explanation. AI will explain that why it think that it will not rain today or it will rain today. So it would give some justification to its decision also. This part we haven't discussed in the previous slide. So see, this is a very, very interesting and very significant part of the agent. So we are not blindly, going to rely on the message that the AI is saying. It is giving a reason that justifies its action, right? And then we can actually see that justification and try to understand, try to understand that how this, how I put it. I mean, if that AI is really giving me a good decision to take the, umbrella or not. I will just, introduce a small term here, which you may have seen, heard before. That is called hallucination. So hallucination means sometimes it can happen if not designed carefully. The AI agent can say something that has no basis, that has no, ground truth at all. So it may just, falsely lie to you without any facts. So this kind of reasoning helps us to keep track whether the AI really have a, fact checking capability or not, right? So this is how a simple AI use case, I mean, this simple use case can tell you how an AI system can work. Okay. Any questions here? I have seen already some questions about AI automation, or tools for automation. I would try to answer that later. Okay. Any questions in this slide? Right. Moving on. So I will just compile a few more use cases where this agentic AI can be very useful. You can see here that manufacturing and quality control, financial fraud detection, loan processing, right? IT help desk automation, all of these use cases can deploy an agentic AI-based solution. But a very important point, for that particular domain, someone needs to design an agentic AI system, right? At least as of today. So, I mean, it's not that a general AI framework will be applicable to all the use cases. So you need some machine learning engineers, some data scientists, some data engineers, to put together, to sit together with the person who knows the business logic, and then you can design your AI, agentic AI network for your particular use case. Of course, there are some templates that you can use, but for every single organization, there are small differences for which you need to redesign this thing. I got a question from someone raised a hand. So can you, unmute and say the question? Himanshu said, provide PPT. Oh, sure. I will. That's not a problem. Right. So see, I mean, I am making a very important statement here. Try to understand the importance of the statement. I'm saying that, yes, agentic AI is very useful. But suppose you have a bank. Suppose you are working in a bank, and for your bank, you're trying to make an AI system that will help you to decide uh, the loan eligibility for customer, right? Now there are AI systems that does it for you, but you simply cannot just download the AI system, feed some data to it and start getting results by clicking a few buttons. It does not work that way, because your data can have a very different domain, or there will always be some interesting points in your data which that AI have not seen. So the best way is to get an AI template or design an AI template, bring some machine learning engineers and the data engineers and the business logic experts, sit together, think what do you need, and then the AI solution will be built. Now, once it is built, then it would start improving. As I said, the first, you just have to give the first push to the wheel so that it can, roll on and, get momentum. But the first thing, still, it needs human to intervene and, do something for it. And that is why I said limited supervision. I have not said no supervision at all. So this is needed also during the process. Some maintenance is could be done, and this way we can kind of excel in making an agentic AI system. Okay. Any questions? Okay.
So
I'm
basically,
moving. Yes. Yes.
so basically, sir, there are two. I can say two bots. Like one is the user defined, so domain based, and second is a generic, right, sir?
Uh, yes, you can say it that way. But see, the generic is not very far from the generic is not very far from what the user is designing. They are not different, I would say. The generics are already there. The
Okay.
user specific agents, agentic frameworks, they adopt the generic ones. Okay. Right?
Like sir, we have in like sir in banking system we have different bots, and in while for aeroplanes we have different bots. So there are
Yes.
aviation companies are there, sir.
Right, absolutely. I will give you another simple example. Suppose there are some generic frameworks that can process text data, right? Now you
Okay.
have you are a you have a website that run blogs. Now you can take that particular framework, which is a generic one, but for your type of blog, you need to add a few more things to it. Okay. I mean, now after you added those things, this is your own user-centric AI. Okay. Yes, Himanshu, you want to say something?
Sir, can we differentiate between agentic AI and generative AI?
That's a very good question, actually. Okay. So see, generative AI is a specific type of AI, right? That generates something. For example, text. It can generate video. It can generate image. It can generate graph. It can do a lot of stuff. That is generative AI. Now, this is a general concept that you input something and you get something out of it. Agentic AI is actually a strategy. It's not, a specific model. Now, say we are trying to build an agentic AI that reads the company revenue data and produces a graph. Now, in order to do this, we need an agentic AI framework which may use some generative AI models. Right? So, the generative AI is a tool that the agentic AI will use to achieve something. So, the agentic AI is actually the process of achieving something, where the generative AI is a tool to accomplish this. Okay? Any other questions?
No, sir.
So can we say that, sir, agentic AI is more valuable than genetic AI? or something
See,
like that.
if I will not, we should not say in this way, because see, if there is no generative AI, agentic AI cannot do a lot of stuff. And if there is no agentic AI, then only generative AI cannot achieve a lot of stuff like this. So both of them needs both of them. That is why we should not be comparing based on the quality of, I mean, based on the importance of them. They are two separate things, and both of them needs the other, right? I mean, again, a very bad example is coming to my mind. Say, you have a television and a remote. Now, which one is more important? You, you cannot say this, right? I mean, yes, it appears the television is everything, but unless you have that remote, it will not run. And if you only have the remote, it does not make also any sense. So, something like this. Okay, any other questions? All right. So, here are a few interesting implementation frameworks that people uses to create agentic AI. So first of them is LangGraph. The second one of them is AutoGen. The third one is called Crew AI, and the fourth one is AWS Bedrock Agents. Now there are plenty more. A lot of other frameworks are also possible. Is there, but I'm only talking about only these. These are always comes within the top 5, right? So what they do, they actually, if someone wants, if a developer, I mean AI developer wants, he or she can skip everything here. They can simply start by writing own code and make a framework of its own, if needed. And we sometimes do that also. But if we use a framework like LangGraph or AutoGen, it does a lot of heavy lifting for us, and with less amount of code, we can build a more complex system. Okay, so essentially we are trying to reuse a lot of stuff through this framework, and some common work we let the framework to handle. So different organizations have created these different frameworks. I would like to talk about only the LangGraph part, because this is something that we use very extensively in Tatras, and a lot of other organizations also. Now, LangGraph is actually something that comes from LangChain. I don't know if you have heard this term LangChain or not, but LangChain is the most famous framework in the generative AI world, and particularly for text. So you are using GPT, you are using Gemini, you are using Cohere, you are using Meta, whatever you are using. You can actually, in code level, you can actually use them very effectively using the LangChain framework, right? Now, LangGraph is something very interesting that is built on LangChain, right? So what does LangGraph contains? Here is some reason that why we are going to talk about LangGraph. I am not going there, but the most important thing is that it's a graph, and whenever we have a graph like this, it's very convenient to design very complex systems. I will give some example right away. So let me show this, right? So whenever we try to develop an agentic framework using LangGraph or any graph-based architecture, most of the frameworks are graph-based architectures. We have these kind of things called nodes, state, and edges. So nodes are actually your agents. You remember that I was talking about agents at the very first line. So say I have a let's take an example of the the weather example or the company revenue example. So an agent that will find out the 5 years revenue of a particular company. So one agent can be there that will only pull data, given a particular query. So this can be one agent. Another agent can be used to just compare some numerical data and produce relevant statistical information. Some agents could be there that are very simple, that can do, addition, multiplication, subtraction, this kind of basic operations. These are some, example of small tasks that agents can do. Now, every agent like this can be represented by a node in the graph, right? So you can guess that if I have 3 or 4 type of different tasks happening in my network, then I will have 3 or 4 different nodes in my graph. Next is state. Now, definitely you can guess by now that every agent communicates with each other, right? So that is why it needs to send messages from one agent to the other. Now, this is achieved through a very structured messaging system called state. So, state is nothing but basically a structure where it follows a particular type of schema to send a message, right? Let's keep it this simple. Then we have ages. Ages are actually very simple. Ages will tell how your workflow will look like. So from which agent to which agent you should have a connection. This ages will tell. So the idea is pretty simple. I will very quickly, give you some example of the graph. Then you will understand that, what is happening. So let's take a quick example of how this kind of graph architecture works. So you see, this green one is a user or human who is asking some question to AI or LLM. Say this is a generative AI side. We have another piece in our engineered block, which is tools or context. So tools are actually something that, provides us the data. You remember the perceptron part, right? Perception part, where it gathers the data. So tools are actually something that gathers the data. Now, every communication has a separate message. So when a human is sending something to AI, that is called human message. When AI is sending a message, then that is AI message. Now the AI can send a message to the tools, or the AI can send the message to user also. When tools say something, then we have something called tool message. So whenever you have a state, like I showed before, state is actually a sequence of AI message, human message, and tool message. So whatever be your conversation is happening, or your workflow is working, everything that is being communicated is stored in a form of a message, and your state is a sequence of those messages, right? So this is a very important part of any agentic AI framework, which is called the message. Now, I will show you a very simple use case, right? A simple chatbot with tools. So you see, our agentic framework looks like this. That this is start. I mean, from here, the execution is starting. This agent is a chatbot agent. This is a generative AI agent, right? What it can do, it can see some text and it can generate some text based on that. Here, I also have a tool. Now, what is a tool? A tool retrieves some information from our data source. Now, this is the interesting part. Say I am asking a question that who is America's first president, something like this. So this question is coming from here. Okay. So who is America's first president is coming from here. Start to chatbot. Now chatbot is now calling the tool through this edge. You can see a dashed edge here, right? So chatbot is calling the tools, giving a message that, hey, fetch me the list of all American presidents and also the year, right? When they became the president. So tool have seen that, and tool does not need anything to do anything, any decision making, anything. Tool will simply give back all the messages like that in that way, right? So now the chatbot have gathered, based on the question, the chatbot have gathered a list of American presidents chronologically sorted. Now its job is easy. By looking at it, now it will take an action. So it will give an action that, well, I have found that this person is the first president of United States of America. Now it will return the result here through the end. So this, you see, this is a graph because we have, 4 nodes in the graph, and each node represents an agent. And this is how the agent is, connected with each other and solving a complex one. Okay. Let's not, read everything of them. This is basically for more technical discussion, but this is how a particular agentic network can look. It's a very simple one. In the next slide, I will show you a more complex agent. But is this, understandable? What is happening? Any questions? It may be a little overwhelming at the beginning, I understand, but try to get some takeaways from here. You don't need to understand this in very technical way. Now, another thing is, see another example of an agent. Again, this has 1, 2, 3, 4, 5 different nodes. So, and I have 3 agents here. One agent is there a question in chat? How to work agentic AI? Well, that's a very big question. Okay. Now you see here are 3 different agents, right? Like supervisor agent, research agent, and manager. Again, let's take the example of the company revenue, question. So the research, see the main agent, which is the supervisor agent, it does not do anything on its own. It will first break down the problem, say that, okay, I need to find out the revenues of the company for the last 5 years or something. So it delegates the task to the research agent. And the research agent can have its own tools and everything, and it will, gather all the information and everything, and it will, get back, give back all the information to the supervisor. Now, once that information is present to the supervisor, now supervisor will see, well, I need a comparison. Now, comparison means mathematical operation. So let's not give this to the research agents. Let's consult our math expert to do these things. Maybe this math expert will give me some statistical insight of the data and will, tell me something more interesting. So the math agent only does these statistical inferences. So it will do that and it will return the result back to the supervisor. Note the dotted line and the connections between these agents. They are communicating with each other, right? So now that supervisor has something, a complete answer, the supervisor will check if this answer is sufficient against the question. If not, it can re-invoke the research agent or the math agent. Once the supervisor sees that, well, it's good, I mean, the answer is good, then it will follow the path to the end and it will return the result. So this is how this whole supervisor-based thing can work. Now the question is that how you will design this, how you will develop, how the supervisor is doing all that stuff. Well, there comes the generative AI. Now, the power of LLM, crafted for these specific objectives, can help us to do a lot of stuff like that. Now, the most interesting part, and which is basically the conclusive part of my discussion, is that this is a very complex work. That finding the revenues of the last 5 years and do something for me. We cannot do that using a single LLM or a single generative AI call. That would be very complex for it. And it will definitely hallucinate, it will be incomplete, it may not even return the results. But if we make small generative AI modules, each having a separate work and orchestrate them together through the framework, then we can get something like this. And we can extend that idea to make more complex architectures. So that is how our agentic AI frameworks basically work. Here you can see that in this particular framework, we have used executors and supervisor type of nodes, which kind of helps us to orchestrate, research, math related work, and whatever be your use cases. But these are like a templates. Now, you remember I was talking about the templates. So this template is you can adopt and change the agents as per your need, right? You can add more agents to the network. You can, modify a part of the agent to, your purpose. Like for your banking, imagine this to your banking sector. You are modifying this research agent to look at your banking data. You're modifying the math agent to do financial computation instead of scientific or statistical computation. And then this template is now ready for your own banking solution. Now, there you can see the difference, the process of how we can adapt a template to a user specific work. Okay. This is how, this agentic, framework can create. The question is there that how to create agent. This I'm, not going very similar type of thing, but maybe too complex, to discuss for now. But I will share this thing. I have some references here in my slides also, which you can, look into this. So I have 4 use cases listed here. I explained 2 of them. I am leaving the rest 2 because they are more complex and more technical. We can skip this, for the time being. But the question is how we will, okay, sorry. So the question is how we will, implement this. There comes the land graph. So you have to code for your agents, right? But you don't have to code a lot. Here is your land graph framework, which will allow you to write a single line of code to create one agent. Another few lines, very few, 1 or 2 lines to connect 2 agents together. And then you have everything. So this is where our Python frameworks for generating codes, they help us. And these frameworks not only for Python, right? LangGraph is Python, but there are AWS agents that can be used for JS or Java as well. So depending on your platform and the language on which you have created those things, there are plenty of deployment options for you as well. Right? So, of course, the most of the deployment options are in Python that I'm not arguing with. But if you have, that skill of developing this Python-based frameworks for the agents, then you will be able to create a custom agentic AI for any solution that you have. So you have to understand that how that business logic works, and then you can do this. There is something that we do in Sabudh also, like, it's a very, we do projects where these kind of frameworks are very interesting and can be deployed. So that would be very interesting if you do that, hands-on. This is not a very, quick thing that we can immediately show you, like a 1 day of, a workshop, a hands-on session of 1 hour will not tell you anything about this. It's actually a little longer process. So it will need some time to kind of ingest the strategy and, get the ideas, to going. I will not, explain any further. I believe I tried to give some insight of how an agentic system works. I know there are many questions that I couldn't answer in this, small period of time. But I have my email given to you. If you send your queries to me, I will try my best to answer them. But this is in general how the agentic AI system actually works. There is a very famous film that recently released in Netflix. I would suggest all the people, all the AI enthusiasts who are present in this workshop, please have a look at this if you haven't already seen. This talks about a lot of dilemma and the technology that is happening in the AI from a very grassroots level. So I am very impressed with this movie. I would suggest that if you get chance, you should have a look at this. It's a very small movie. 1 hour, 15 minutes or so, more like a documentary, but it's a wonderful thing. And answers a few questions that you may have regarding, the responsible AI. Okay. That would be all from my side. I know this was short, but I would try to answer some questions. So one question getting based AI agent tools and need to coding, yeah, only work tools. I'm using agent tools to create chat boxes. Yeah, it's fine. I mean, as I said, see, I mean, any framework, anything or anything is good. I mean, if it suits your business need, it's fine. So either you can start from native way, starting everything from scratch, building, brick by brick, uh, or you can use this thing to build your own agents and stuff. But what happens when you use a framework is that if you want too much customization, then these frameworks may not be sufficient to provide you those customizations, right? So then you may need to go back to something like this land graph or something that will give you more flexibility. Any other questions?
Yes, if anyone has any sort of questions, they can ask from Sir. And if possible, try to open your mic option and ask the questions, because Sir is sharing the screen right now. So he might not be able to check the chat box again and again. It's the request for all the upcoming sessions as well. So yes, any questions? Sir, I can see a few questions in the chat box. How to own AI agentic tools or create?
I mean, if you see, tools are basically simple functions, right? So if you want to create a tool, then you can actually use the wrapper provided by your language, like Python or Java, to convert these to a tool, right? But there are some off-the-shelf tools are also available, like Google search tool, Tably search tool, web search tools. These can also be used. So again, you have multiple options. Either you take an off-the-shelf tool if that suits your need. If not, you can make your own function calling whatever you have, and you can make your own tool. Most of the frameworks give very nice connectivity to data sources like SQL or other kind of data services as well. You can use them to create your own tool as well. Any other questions? The next speaker is here, so I should drop off.
Thank you so much, sir. If there are no other such queries, then we will be ending this session and starting with our new session. Thank you so much, sir, for giving such a wonderful insights over the topics.
Thank you. Thank you, everyone. Bye.
Bye, sir. So let's just.
Thank you, Partha sir.
Okay. So let's just start with our next session, and the next session will be on ChatGPT in action and building smart AI assistants. In this session, you will get a practical session on using ChatGPT and exploring its real-world use cases in automation, learning, and productivity. And it will be given by Mr. Bhapaditya Chakraborty, who is a lead data scientist at Tatras Data. Over to you, sir.
Thank you. I guess people here have consumed a lot from Partha. So I'll be starting with some discussion, and then you can have a breathing space and water break kind of, not tea break but water break. I'm sharing my screen. So today we'll be discussing. We have already probably heard about these agents and all complex things that people have built around this normal LLM calls. I will try to cover a few things which is required to do these LLM calls and make those LLM models intelligent enough to respond to your need, and see what are the different types of things we usually solve, including prompt engineering and all. So uh, if this screen is visible, right? I mean, I know this is VS Code and black background, so if it is visible, a few things that I want to mention over here. I have used LangChain framework in my calls. These are not native API calls that I'm doing. LangChain is a framework which provides a wrapper, the wrapper that Partha was also talking about. I mean, to create agents, to create Lang graph kind of thing, intelligent and human in a loop kind of communications. You may need to take help from these wrapper functions or wrapper libraries that have been built. Uh, you know, so I'll be using LangChain framework here. How and again another thing that I have done over here, there are many LLM service providers are present. I mean, Gemini is one of them. OpenAI was the ancient one. So I am using OpenAI here. But if you move towards other service providers, if you want to use Gemini or Grok or Claude or anything, few codes will change. I mean, how you are invoking the models and all. So those are available in these wrappers also. So you can see, the first thing that we will do, we will try to connect with OpenAI's model, some LLM model, and we'll try to see how through Python code we can communicate. I mean, probably asking a simple question and see this trained LLM is responding me. Hmm. The first thing that we needed to do is to create one OpenAI key that you need to be, you need to create that from OpenAI portal itself. After logging in, signing in, you will have the option to create OpenAI key. Probably till now, they are providing few free credits to use, and then they are like pay as you go kind of pricing is there. If you are using Gemini, then again, Gemini Cloud portal, you can log in and you can see, you can create an API key, and Gemini, Google is providing probably $300 free of credit for the learners to explore things. So these are interesting. Um, the key of OpenAI looks something like this, a long thing that you can see. I can just show you. I can't copy this thing to you. You have your own key. I just provide that OpenAI key to one environment variable named OpenAI underscore API key. You set that OS environment variable. That OpenAI key will work. Few libraries that we probably will need. These are here, and if I share this Jupyter, it will work. LangChain and LangChain OpenAI, these two libraries you need to install. These are framework. And then after setting the OpenAI environment, here in this line, through LangChain's given wrapper function, wrapper class basically, we are creating a LLM object. When here your LLM model is getting initialized to Python code. You can see chat OpenAI is a class basically where you can pass this model name, and according to your model name, the LLM object will get created. So I have used GPT-4o mini. You can use GPT 4.1 mini or GPT-4o, GPT-5, whatever it is. The names of those models are available in corresponding service providers portal. So you can just pass them. So one LLM model object will get created. Let's execute it. Now, our first task is to just communicate to this LLM model, GPT-4o mini, which is running in OpenAI server. I will try to post one user question and see whether it is giving me the answer or not. Right. The standard syntax of using this LLM that we have created is this invoke function. You have to actually hit llm.invoke and pass your question over here. It will internally call that OpenAI API and it will return you the response if everything is fine. So here is this function, simple conversation, which takes as argument the user question. And then ultimately we are doing llm.invoke, passing those user question to LLM, basically GPT-4o mini. And the API will execute, will take some milliseconds of time and return the response accordingly. I'm returning that response of content over here. So what can be my question? What is LangChain and why it is useful? Let's say this is my question, or let's make it some bit simple. Right? Say I'm asking what is the capital of India kind of. This is one human given question which is getting now transmitted into LLM's portal, and then a trained LLM will, from its knowledge, try to give me the answer. So simple conversation is this function I'm trying to call. I have passed this question over here, and I will see what response I'm getting. Right. Let's execute it. So it was the question, what is the capital of India? And this is the answer that I have got from the capital of India is in. You can actually now execute the complex question about LangChain, what is LangChain and why it is useful. Execute it, you will get a better crafted response, a long response kind of. Thing is, I guess now OpenAI's latest model is being trained up to 2023 years data, up to that point. So some event which has occurred recently, probably yesterday, so it won't be able to answer correctly on those events, definitely, because it is not doing Google search or anything. We have not implemented any tool. It's just trained knowledge from where it is giving me the answer. So what is LLM, LangChain, and why is it useful? This is the whole answer that LLM has given me. And it took kind of couple of milliseconds. Let's make it scrollable LLM. So you see there are many things that we have given. Key features of LLM. I have not asked for it. Modular design, retrieval, augmentation, generation, chain management, memory management, etc. etc. I mean, basically speaking about feature of LangChain. What are the different things that you can do, use cases, and then benefits, too many things. And then again, a summarization kind of thing. So it totally depends on how you are asking the question. It will provide you corresponding answer in that particular format. It's a very simple conversation we are doing. Okay? Simple code. Now, if I move to a bit more complex thing, I mean, for example, it may happen that I want to build a chatbot which can provide me answers based on my documents only or context only, right? It may happen that I have few private data, private documents, which is not publicly available. So definitely when this OpenAI model got trained, it had not accessed those documents and probably it don't have any knowledge about that because it was totally private to my organization, right? But I want to build a chatbot on top of that. So definitely, if I throw, my specific question, very personalized, or question about few very, personal documents, secret document, it won't be able to give answer in those cases, or probably even if it does, it will come up with wrong answers or hallucinated answers, not very strong answers, kind of. So in those cases, what usually people do, people try to provide the context and then craft the question in a way that LLM will look at my provided context only and try to craft answer from that context only. It won't use its own publicly available knowledge to answer my question. I will provide the question, I will provide the whole context, and I'm trying to craft answer from that context only. That is another problem, right? So, any question here, guys? Okay, if no, I mean just turn on your microphone and ask me here. I'm not looking at the messages. So the next, usually what people do, they, try to use LLM in a way that, I will provide the context and you have to answer from this context within, kind of. Don't use your publicly available knowledge because, I don't need those historical information. So answering with context is another thing where you can see the difference between the first function and the second function. In the first function, I had only provided the question as a parameter. Here I have to provide the context as well as the question. And this question will be answered through this context only. Now see, again, our ultimate goal invoking the LLM is the same line, LLM.invoke, and the formatted instruction or whatever. Earlier we were only providing the question here, but here I have to provide a formatted instruction to my LLM. The function is LLM.invoke again, but how to format this string? So here a few things extra are to write. These pieces are called prompts, basically. Now, prompts are simply instruction that you are providing to LLM. LLM is intelligent, but it is not intelligent enough that it can understand your what you want, basically how you want the formatting style, or exactly how much you want. So these details definitely it will never understand. So you have to instruct LLM. See, this is the question, I want the answer, this is the context, and this is how I want the answer. And probably you need a very brief answer, kind of, or probably you need very detailed bulleted point kind of answer. So these are the instructions that you need to provide. How to provide instruction to the LLM is the prompt engineering, simply speaking. Uh, as if you are giving instruction to a very intelligent person. So the good kind of instruction you will provide to that person, the person will understand good and he will execute good, simply. So writing a good prompt, writing a good instruction is basically the whole thing of prompt engineering. There are a few best practices. You do this, it will work good. You do that, it won't work good, kind of. So here you can see from LangChain core, again, the framework, you have a prompt template kind of class available. The prompt template is creating a template for you, instruction template for you. Inside this prompt template, you can pass two different things. One is the template itself, where you can see the template looks like this whole thing. This is a string, basically. Now, here we are saying that you are a helpful AI assistant. Use only the information provided. Look at this piece. Use only the information provided. Why only is given as bold? Because I want to focus only in the information that I am providing you to craft the answer. Don't use your publicly available knowledge or trained knowledge to provide me the answer. So focusing on only in the context below to answer the question. If the answer cannot be found in the context, say I don't have enough information to answer that. That means with this instruction, I am guiding the LLM how to answer my question. Here I'm actually specifying, only consider my provided context to answer it. If it is not there in the context, say I don't know, basically. You don't try to craft answer from your historical knowledge. So these are the instructions that I have to provide. Along with this instruction, I'm providing the context from which the answer will be crafted and the question itself. What is the question? Whose answer I will create, kind of. So this within curly braces, these are basically placeholders in the prompt template. So the prompt is a string, the template is a string, where I have two placeholders which are variables. I can pass different questions with different contexts in the prompt template, in the same template, and I will have the answer. Here, specifying here input variables, two input variables are here. One is this context variable, another is question variable. So I've defined, these two are my input variables in the prompt template. So that's how the whole prompt template is being made. Few static instruction, which is string, and few dynamic position where values can vary. Now, this prompt template, this variable dot format is actually kind of string formatting, where I'm passing the actual context and question for me. Now, context will be passed as a parameter in this function. That will be set over here in this context position. And question again will be coming from the functions parameter. It will be again set into this position of the question. And thus the whole template will have a shape. Now I am doing lm.invoke again, but instead of passing only the question, I'm passing the whole thing, the whole template over here, which contains the context, question, and my generic instruction. The whole string is going inside. And it will be following those instructions, looking at the question, also considering the context. It will work accordingly and provide me the response. This is what changed over here. Now, question can be anything. You can write question according to your need. Context is, in this case, I have considered one text file. I have created basically a text file by copying few things from Wikipedia. So you can see this is a text file which has paragraphs, basically too much paragraphs over here. There are something about transformers or history of the LLM kind of text is there. So what I'm doing, I'm reading that history llm.txt where I'm getting some text basically. That text I want to pass as a context. So basically, this history llm.txt is containing history of the LLM kind of paragraph. Now I want to pass that paragraph into my LLM call, and then I will ask question. If that question is answerable from that paragraph, it will answer it. If it is not, it will say, I don't know. So I have read with Python, this is basically a string. Now, example one, I want to do content summarization. So this is my question. Can you summarize my content? This is becoming my question, basically. The question one would be, can we summarize the history of large language models in 3 to 4 sentences? So look at these things, you just discard this piece. It will create summary according to its own understanding. It can be huge also. But I'm restricting here. I'm saying, do this summarization, but within 3, 4 sentences only. And this is becoming my question. And now I am calling this function answer with context function that I have created over here with this context, this whole context that I have read from the document and my question. In this case, this is question. Let's switch off the other example. And if I execute it, question was summarize the history of large language model in 3-4 sentences, and there is this answer. Large language models begin to train whatever. I can't show you the full thing prominently because it's Jupyter notebook, but I can just copy this phrase. If I copy it and paste it somewhere in probably Word document, then you can actually visualize the whole answer. So this is what it has given. Let's make it a bit dark. So see, this is what is being responded. Large language models began to gain prominence, etc. This is this. Now, now this is fine. I mean, whatever was there in the context, based on that, it has created a summary. Now, what are the things that I can do and play with the prompt? So let's try to change this instruction a bit, right? So I'm saying summarize the history of the large language model with the same context. Instead of saying in 3-4 sentences, I can say bullet points only critical information, probably, right? Let's see whether it is following my instruction and creating a bullet point actually. It was a paragraphical response at first. Now see, the structure of the answer got changed, right? So if I copy it and paste it here, where I was doing that, here it is. You see, basically, these are bullet points. Now I have copied those bullet points from Jupyter Notebook to Word document, so that's why it got a bit unorganized. But basically, point-wise, it has created, it's not in a paragraphic summary, it's point-wise summary. It has followed my instruction well and created bullet point summarization or key point, key information extraction kind of workflow. So this instruction, how you are giving the instruction based on what you will receive the output, right? And this is a task of prompt engineering that people will do. A very simplistic example of that. How you are instructing, that's how it will perform. Right? What else can we do? We can do one thing. See, in my generic prompt, I have provided that instruction that, if the information is not available in the context, say I don't have enough information to answer that. And let's check this thing, I mean, answering from the context only is working or not. If I ask, what is the capital of India here? Let's see, it should tell me, I don't know, or context don't have that answer. See, I don't have enough information to answer that because it is only looking at the context itself. So creating a boundary without, I'm not using the trained intelligence of LLM here, but I'm utilizing the capability of the LLM. It is reading my context and crafting the answer. If it is not there, then it is saying, I don't know. But if you do it here, just, forget about this only thing, use the information to provide the context, the answer can be found in the context. Instead of this, I can say this, but, use your own knowledge to answer it. Then it should answer it basically, even if it is not in the context. Now see, now it has used its own knowledge because I have instructed it to do that. Right, capital of India simply now it is coming. So this is example of prompt engineering that people do. Okay, any question here? Or any question which is coming to your mind, which can break this behavior? No? Okay. Now let's see, as I was showing you, you can instruct, LLM will follow that kind of instruction, but how, there are few good practices basically defined by different service providers. OpenAI has its own best practices written, which you can find in OpenAI's portal. You just have to search, prompt engineering best practices for OpenAI model. Right? How these models got trained based on what, it depends, how it follows your instruction. And there are few guidelines that are being made, which is basically backbone of prompt engineering, where they're saying, do this, it will work good. Do that, it won't work that good, kind of. So prompt engineering guidelines, it can show you what are the best practices. Now, first thing is, the first point, now I have just captured couple of examples, 2-3 examples here, but there are many, but in general understandable. So first thing is, you have to be very specific and clear about your instruction, right? So a example of bad prompt or vague prompt can be, tell me about transformers, and then we are passing the context, the element history context, right? Now definitely this context has few information about the transformer, but I have just instructed, tell me about transformer. What to tell, how to tell, how much to tell, nothing is there. So it will, it will provide you some answer, fine. But a good specific prompt kind of example should be, based on the context below, explain what the transformer architecture is, when it was introduced, and why it was significant for language models. So here in this case, I have actually mentioned in my instruction how much to extract, how much to provide as an answer, instead of generically saying, tell me everything you are looking at my context, right? So this is what people are saying, good prompt versus bad prompt example, where specific versus non-specific and clear instruction kind of distinction is being shown over here. I will execute it and you will see how things are going on. Then again, another example could be, providing clear instruction. See, this is again my context, which I have read from this history llm.txt is a very long text. In my llm.invoke function, which takes template or, whole textual information from which it will follow the instruction, guide me through the answer and all. I'm just providing this whole text, LLM history context that I have read from the document, and only provided this particular term, GPT model. So this is becoming my whole context, which is going inside my LLM model. Now, actually what to do, that I have not provided. No instructions basically. The whole context is going, and just I have added one term, GPT model. Now, what to do with the GPT model? Do you want, summarization or focusing on where the GPT model is being used in the context? So basically, I have not given any instruction. I will execute that and you will definitely see the output is definitely telling something about GPT models, but it's kind of long. Probably you don't want that. But a good clear instruction with format could be, use only the context below, list the GPT model version mentioned, format your answer as a numbered list with the year each was released. So actually my intention was to, figure out from the context different GPT models, their year of release in a more formatted way and more organized way with probably one single line of description. So I had that in mind, but I have not instructed that properly to LLM. So this is one example of bad instruction giving, and this is how you should be giving the instruction to the LLM. Okay. With formatting information. Third case can be, with the instruction context, whatever you are providing to LLM, you can also provide few examples. output examples to display or show it how you want your output to be, right? Exactly how you want your output to. So it will have a reference that okay, someone is instructing me something and he needs the output in a specific format, probably one liner description, probably organized in a more organized way, etc., etc. So you can use examples in that also. So here a bad prompt can be extract key dates basically without showing desired format. So I'm saying extract key dates from the text, right, and passing the text. So I just truncate the text to make it faster. So you want extract key dates to be extracted from the text, and how to format? You rely on LLM's own knowledge or LLM's own interpretation of this array. Instead, what we can do, I can tell again, extract key dates from the context and format them as shown is the example. Now I can give an example over here. Example format, I want it in that way. 2017 colon the mm, the event name or model name or whatever. 2018 some event name or some model name. So I am telling LLM that okay, see, provide me the information as shown in the example itself. Colon something something. It need not to be XYZ event or whatever. These are the formatting examples I can give. So definitely without the example, it will show you something. With these examples, it will show you in more formatted way. Okay? This I have showed you 3 different examples where a good style of instruction giving or bad style of instruction giving, how to pass examples to guide LLM through. So these are being shown. So I can execute this piece and see one by one all these outputs. The first one was be specific and clear, where back prompt that we used, tell me about transformer. That was the prompt basically. It will generate some response, which will be huge. Let's wait for the LLM API to complete its invocation. The first one got executed, I got a response. And the second one was good prompt, where explain what transform architecture is, when introduced, and why significant, but specifically mentioning what I actually need, kind of. So that has also produced a result for me. So if I copy it, paste it over here. Is the one thing I had printed a portion of it. Instead, let me print everything. Okay. Tell me about transformer. That was our vague question. Copy it, put it here, see what it has produced. Yeah. This was example of bad instruction giving. Too many things. Transformers are type of neural network, too few things here, and then a summarization version, etc., etc. And the second one, hopefully that got executed also, where I have specifically mentioned what to do. This was the first one's response, and this was the explain what transform architecture is, and very specific. Copy it versus put prompt. You see, it is more organized. So first paragraph is telling about the first part of my question, second paragraph is telling about second part of the question, and then bulleted point things, which is talking about parallelization, scalability, attention mechanism, and then a brief summary, kind of. The second one looks more organized version of the first one. So that's what my instructions are doing over here. Similarly, think about the GPT models one, where no instruction is being given, only the context. So he did something, came up with too many things, and then everything basically. And then we came up with this few shot learning where I had provided it, how a few examples of how to craft the output format. So extract key dates without showing the desired format was producing this kind of thing. But with good prompt, it has produced something like this. Before 2017, it was there without the information, output example. But with example, it has produced prominent things. I mean, I just want year, then colon, one single sentence, kind of. That was the prompt example that I had given. So this is how it is working. There are few challenges. Challenges in the sense, while providing context to craft answer, the limitation is how much context you can provide in a single call. Is there a limit? So definitely there is a limit because every transformer has its input limit, how many tokens it can consume in a single go. The number of tokens nowadays are too high, but still there is a physical limit present. So for these kind of models, cutting edge models that we are dealing with right now, whether Gemini or OpenAI, they deal with around 32K or 64K input token limits. You cannot go beyond that. So basically, people are saying if you have a 400-page novel, basically extracted, right? So you cannot actually pass the whole context of the novel to the LLM in a single call and question it, basically. So how to deal with that? Probably want to build one chat bot kind of application where um, one novel is being shown to the LLM and then want it to answer whatever question I have from that novel. So my context is the whole text of the novel. It is 400 page or 500 page long novel, right? So limitation is you cannot actually pass the whole context to the LLM in a single go. Then how to do it? Similarly, in output also, there is a token limit. How much token it can produce in a single API call. It transformers output dimension is also fixed. So output token limit is also fixed. So you don't expect it can produce you too long kind of output. There is a physical limit there. So organizing the output structure, probably the output expectation should be in more formatted way rather than paragraphic way is a good practice. But the question lies how to provide input context to the LLM. There are different solutions being made. So do you have any idea about, if we are dealing with very long context that I cannot provide to LLM because it will then go out of its boundary, then how to deal with those kind of cases in real life? If you have any idea, you can share. I'm taking a pause over here to think. Anything, guys? Or any question that is coming into your mind up to this point, whatever I have shown briefly, just conversing with LLM, OpenAI is the use case. Then The second case was providing a context, how to provide instruction to make it follow the context only, restrict it from using its own knowledge. And we have seen, if that kind of instruction I can provide, and it will definitely look into your own context only. It will not use its own intelligence to answer this. So these are two things we have seen, and all Python codes basically. So any question that is coming into your mind? Could I go ahead?
So yes, everyone. Can we have yeses or nos in the chat? Are you following that sir is just teaching you? Do you have any questions?
No, I guess. Okay.
But sir has just asked you some idea. So could you please share the answer that sir has just asked you?
Even if you don't have, you can tell that we don't have. No problem at all. So, okay. So moving ahead, usually what people do now when they are dealing with very long context, the retrieval augmentation generation, retrieval augmented generation, that term, RAG, is a very popular term nowadays, right? Retrieval augmented generation. How this works? Then there are few different types of models that are available also. We are now dealing with one model, GPT-4o Mini, which is a text-to-text kind of model, where this LLM model understands natural language text and it will produce also natural language text that we have used already. But there are other models too, transformer-based, which are not text-to-text kind of model, embedding generation. They are. I mean, they can understand your natural language textual information. They can create embedding out of it. So the input of those models is basically natural language text in case of textual example, and it will provide a vector. So those models are trained in a way, those transformers are trained in a way that it understand English natural language, English vocabulary. And if we use the encoder part of the transformer only, then encoder encodes the natural language text that I'm providing it. So those encoded vectors, you can assume that those encoded vectors are vector representation of whatever I have written in my paragraph, whatever is there in my question. So every English sentences are getting transformed into a vector information, a numerical array kind of information, which has mathematical interpretation of whatever I have written in natural language. So those vector models are very tricky over here. So from these vector or embedding models, what is our expectation? Our expectation is, if I say, I love cat, it will be converted into a vector or array of numbers. If I say, I love dog, this sentence will again be converted into a vector. These two vectors, I love cat and I love dog, is expected to be semantically similar. Most of these parts of most of the wordings are similar. That's not the case, but the cat and dog. Basically, someone is trying to express through this sentence that he loves pets, kind of. So cat and dog.
So are they converted on the basis of ASCII values or on the basis of characters or on the basis of words?
This embedding vectors.
Yes, sir.
Not on the characters, not on the words. Basically, they are being trained with tokens. Tokens are loosely speaking. These are not exactly words. For example, if you see these words, sentence hyphen transformer, this can be a word for me. But when you tokenize it, you can see sentence is a token, this dash is a different token, and transformer, this is a different token.
So now, if I had, for example, sentence and sentences, so are they two different tokens, sir?
They will tokenize the whole thing.
Okay.
You may have one single sentence or list of sentences, basically a paragraph you can pass. But internally, how these models are trained, they transform this whole English language, natural language, paragraphs into tokenized sequences. They trained in a way that they understand tokens and they can produce vectors.
So they are doing lemmatization, I think.
They are doing nothing. They are doing tokenization. Tokenization is a different thing. They are not processing the sentences as a sentences. Right. There is a transformer model which is consuming these things, the models are being trained in a way that it understands the tokens and then, create a vector out of it. You learn about tokenization thing, how tokenization works. There are tokenization libraries too. You can see how tokenization works. Hmm. So it totally
Okay.
depends on, how to tokenize. It totally depends on how you train the tokenize, basically. Yeah, fine. Another thing is, two sentences or two paragraphs, if they are talking about same thing, if they are semantically, meaningfully similar, not exactly same, the corresponding vector of those sentences or paragraphs should be close together. I mean, if you create a cosine similarity between these two vectors, which are talking about same thing, you will get very high similarity score there. So I love dog and I love cat, these two sentences, if converted into vector, these two vector will have very good similarity, 90%, 95% similarity. So with this idea, with this vectorization or embedding generation of models in space, people have thought about a solution where they are saying, okay, I have a very large context. I cannot feed that context into the model itself as a whole. But what I can do, the question that is being asked to be answered from the context, I can create embedding of the question, and then I can find a different paragraphs of the whole context to see which or what are the paragraphs that are close to my question. I mean, in one hand, I am vectorizing the question itself, user given question itself. On the other hand, I have vectorization vectors of several paragraphs of the context that are being provided. The whole context is too large. That probably if you chunk that context into a number of paragraphs, you will end up with having probably 50 paragraphs, something, not 50 sentences. Think about it. So I'm talking about a 400-page novel, and I'm ending up with 50 paragraphs from that novel, basically. Now, if I embed or if I vectorize those 50 paragraphs, I'm dealing with 50 vectors in my context space. Now there is my question that I'm asking, right? This question is getting converted into again an embedding or vector. Now the thing is, the paragraphs, the 50 paragraphs that I have already vectorized and stored somewhere, some of the paragraphs will have very good relevancy with my question, semantic similarity with my question. So I have to figure out those paragraphs only. I need not to look at the whole context, throw it to LLM. Rather, what I can do, I can figure out what are the paragraphs in the whole novel is very relevant to my question only. Fetch those paragraphs only. Probably I will end up having 2-3 paragraphs there, not the whole novel. Then I can pass those 2-3 paragraphs to LLM along with my question to have the answer. This is one technique of reducing the context, getting the process. Initially, what we have shown we can pass the context to LLM along with the question, what I need. It will give you the answer. It has that capability. But I cannot pass a very long context to it, then what is the thing? The thing is, I can filter out the context. I mean, probably the whole context or whole novel is not necessary to answer my question because my question is specific, right? There will be some pages or some part, some paragraphs which is carrying my information, which will be required to answer my question that I have asked over here. Can we filter those paragraphs out and only send those paragraphs to LLM? That was the question. Now, solution is how to filter those questions. Here comes those embedding model. They are saying what we can do vectorization of the whole context, right? So let's see how vectorization works. Vector embedding creation and similarity based retrieval thing, which is the backbone of RAG or retrieval augmented generation. What you need to do, again, see here, I am reading the history llm.txt, which is a long context for me. So this text content, this variable is containing a string, basically, but long string, not a single sentence, a very long paragraph. In LangChain, there is one module called text splitter. Text splitter is, if you have a very long paragraph, long text in front of you, it can split the text into pieces. Now, how to split the text? It depends on many things. You can say like, I want to split my text sentence-wise. I mean, every text will be one sentence for me. I can think of like, every text is a paragraph, basically. So split the whole context into paragraphs. split the whole context into sentences, split the whole context into probably chapters, or split the whole context into pages, page-wise information. So how you are splitting the whole context that you have extracted from a 400-page novel depends.
Like, can you do it for also CSV files?
Yes, why not?
Okay.
But is it necessary? That's the question. Different question. I'm coming to that. So currently, I'm dealing with a paragraphical kind of context. Okay. So now, see, a very good way of splitting text is recursive character text splitter, where they're saying, the strategy is something like this: consume the whole context and split the text in a way so that every paragraph is not equal length, but every paragraph should contain a very meaningful kind of information in within it. I mean, one paragraph is having a meaningful paragraph. Second paragraph is talking about something else. Third paragraph is talking about something else. This is how you split your text. So there are many algorithms present that you can use, or you can craft your own algorithm also. The idea is how to chunk or split your whole text. So just I have used, one popular and already given kind of splitter. So how it works? Just you have to pass this information. Chunk size, chunk overlap. These are optional. Don't give it, it will work also. So chunk size is saying every chunk or every piece of information that I will cut from the whole context should not cross 500 character limit, basically. So each chunk will be almost 500 characters, kind of. It should not cross that. And chunk overlap is how many character overlap should be present in between two different chunks. For example, consider this is the paragraph I'm talking about. Let's take this example. Say this is a paragraph I'm talking about. What they are doing, say this is being considered as a single chunk. Then this can be the second chunk for me, this can be the third chunk for me, this can be the fourth chunk for me, and so on. Piece by piece, the whole text is being splitted, right? Instead of doing this, they are doing like this. I mean, split it. This is the first chunk for me. While doing the second chunk, have some overlap. So take these two sentences as overlap. So this is where the 50 character overlap is coming into picture. Then again, while doing the third chunk, take some overlap of the previous. While doing the fourth chunk, probably take some overlap from the next previous chunk. So this is how we will iterate. Now, why this overlap is necessary? And we can tweak it like this also. I mean, if you place chunk overlap 0, it will be non-overlapping chunking, right? But usually people give some overlap, some percentage of overlap in between chunks. Why this? Just to maintain the continuity, so that I can LLM somehow can know that, okay, if I am passing two different chunks into it, chunk information only into it as a context, then few sentences from previous chunk is being already there in the current chunk, so that if I accidentally cut the whole sentence in between the full stop, kind of, and the sentence is not being completed, but still, my chunk is made with a half-baked portion at the end of it or at the starting point of it, so that LLM can have that thing in the next overlap, next chunk. This overlap kind of thing is being used just to maintain the continuity. That okay.
So 50 is a previous words.
Previous
Number of,
character. Yes.
right,
How
right.
many how many portion of the previous chunk I need to also take into account while creating the next chunk, kind of. You can increase it also. So these are tunable parameter, where in case of LLM, what people do, there are no certain defined chunk size and chunk overlap present, basically. But these are parameters that you have to tweak and see that, okay, exactly what chunk size and what chunk overlap is working best for your case. Your case may vary, your solution may vary, right? Your ask may vary. So you have to tweak it, run it multiple times and see, okay, particularly this chunk size and chunk overlap is working best for me. 90% of the questions are getting 100% correct answer. So this is the best combination. Never. So once we split that, then what we can do, we can transform every such chunk into vector embedding, right? Here I have used a sentence transformer, which is available open source in Hugging Face. So this is a model which is trained in a way that it can consume natural language sentences and produce a vector for me, embedding for me. So I will be using this model, sentence transformer all mini LM L6V2 model, to convert these chunks that I have already created into vector, right? And then
So
where to store.
do I have
Go
to
on.
first import this model or simply write this model's name?
You just have to write this model name over here. It will, in your first iteration, first run, it will automatically download the model from Hugging Face.
Oh, okay, sir.
From the second run, as it is already being downloaded into your temp folder in your local machine, it will not download, rather it will use. Again, what you can do, you can physically download this model from Hugging Face, store it somewhere in a folder, and instead of providing the name, you can provide the path of the model, which is there in your local machine.
Through pip, we can also install this, right, sir?
Not PIP, these are physical files basically. You have to download it simply.
Okay,
You will have a
thank
zip file kind of, right?
you. Okay,
You
sir.
have
Thank you.
to, these are pre-trained models. These are not libraries. Okay. So now the question is, okay, I have say 50 different chunks from the whole context separated out. I will be creating 50 different vectors. Where to store those vectors? Okay. Now, usually to store data, we use database, right? In relational DB, we store data. In MongoDB, we store unstructured data. But these are vectors. So what kind of database I can use to store vector information, embedding information? Here comes the vector database concept. There are vector databases which is capable of storing vectors, which is capable of searching vectors and all. Few capabilities are there. Vector search is a capability. Similarity search, it can do. So Face, FAISS, is Facebook AI provided open source vector DB that you can use. But there are other vector DBs too. It's a good thing to start as a starting point, but you can have Pinecone, you can have Azure or AWS hosted vector DBs to use in cloud, right? There are other vector DB service providers too. So Price is just an example, which will create a local vector DB for you. But in production system, we use cloud-based vector DB so that DBs can be huge. So loading it, storing it every time from your server is basically time-consuming task. So it should be present in cloud somewhere. So if someone is using Azure, they have Azure Cosmos DB, Azure AI Search Vector DB. If someone is using AWS, they use AWS OpenSearch Vector DB. So vector DBs are being provided nowadays by every giant service provider, cloud service provider. Here I have used Face. So chunks and corresponding embeddings that I have already provided. Sorry, the embedding model you have to pass over here, and the array of chunks you have to pass over here. So this function face from document, it will convert chunks into embedding and store it in a vector store, basically. So this vector store, this variable, actually you can save it into your local machine by writing this vector store dot save local. Give a name, give a folder name. So you will see I have given vector DB. Vector DB is a folder which I have already created. So if I do vector store dot save local, you will have this vector DB saved over here with the two files, index.face and index.pickle. So basically, all the information is being saved somewhere here. You cannot open it directly in text format, but these are vector indexes. But whatever, you can relate it with relational DB kind of. So this is my DB. This is my vector DB. Now see what they are trying to do. Say I have taken 5 sample questions. 5 sample questions are treated it. But I can, let's make it a bit small so that I can see something. Let's take one single question. I don't need that. How similarity search works. What I need to do, this vector store that I have already created through this line, If I do vector store dot similarity search, if I call this function and post my question inside it, I can mention how many similar kind of chunk I need to retrieve. K equals to 2, k equals to 3. Let's take k equals to 1. What it will do, it will convert my question into vector. I already have chunk related vectors present in my vector store. It will do a similarity search between my question and already ingested chunks there, and it will retrieve me the top relevant chunks for me. Let's run it and see what comes out. Chunk splitting is going on. So load a document with this many characters. So splitting document into chunks. So basically whatever parameters and overlap I have given, it became 9 different chunks from this paragraph. And then my question was, when was the transformer architecture introduced and by whom? This was the most relevant chunk after natural neural networks become dominant in image processing. This, they were applied to language modeling. Whatever it was, that particular paragraph got retrieved. Now see, this chunk 1 is not the whole context. This is only one paragraph from the context that is being written, right? So that was our intention. So we are saying this chunk, this paragraph contains most relevant information for me based on whatever question I have posted. So I can use that chunk only to craft my answer. So this vector searching, similarity searching came into picture somewhere in middle to filter the chunks out. And then I can again play with my same kind of thing. So what will change? The context that I was providing earlier was the full context. Instead, I will do this vector search and figure out what are the paragraphs that are relevant for me. I will pass those paragraphs only, not the full one. So restricting the context and limiting the context size over here. Okay? So I'm not running this cell basically. I have some examples, just you have to run these cells and see how chunk 1, chunk 2, chunk 3, these things are going inside only, and you are getting the response. So you can play with Jupyter. Okay, we have already reached end of the session kind of. I want to show you another thing. This GPT-4o mini model or whatever model nowadays people are publishing, Gemini or all, they are multimodal model. Multimodal model in sense they can understand text as well as they can understand images, but they produce text only as an outcome. I mean, these are text generation models we are talking about. Obviously, there are other models which can generate videos, generate images. So those models we are not using over here. We are using text generation model. But while talking about text generation model as an output, these models can understand text as well as they can understand images also. So input is multimodal, text, image, right? So here there are few codes that I have written to show you how directly you can pass an image and ask LLM to analyze the image and provide me some outcome kind of, right? So this is one image. Simply, I have opened that image. So this is basically older certificate of mine. Something is there. So what kind of information I probably need from this certificate image? Maybe summarization is a not good task, you don't need to summarize the certificate. Probably you need a JSONified outcome, structured outcome where name of the certificate holder, certificate provider, date of the certification, these are the keys, and corresponding values will be the values, kind of JSON I need. So structured extraction of a document, kind of problem I am talking about. So here the document that I have passed is a certificate, just as an example. So there are a few things that we needed to do while talking with, while passing image directly into LLM's API. You have to convert the image, JPG, PNG, whatever it is, into base 64 format. So this is the code for, converting image into base 64. Then, just a function which is showing you the invoke function, which you already used to communicate, converts with text and return text kind of. If it is not text, then how to pass it kind of. So a bit of information extra over here. You are passing a text, which can be my instruction. You are passing one image, which is the additional context for me in this case. So I'm not passing text context, rather I'm passing image context. So this is the code of that. And then I want to extract key information from this image and return strictly in JSON format kind of instruction I want to give. Find out, whatever you you are looking at this document, you find out everything, kind of instruction has been given. Then a base64 converted image is being passed. Okay. Let's see what it does. It is this get image information. This is executing, and the output will be the output. If you print this output, if you see something like this, the JSONified format, these are the information, key information that LLM intelligently have found from this image that I have found. Issuer, deep learning AI, recipient, this, completion date, course title, everything, etc., etc. Okay. Now you can have things like how it is relevant in real life applications. I mean, you can have projects where people are processing invoices, maybe lots of invoice. So you have to craft instruction in a way that if you pass one invoice image to LLM, these are the fields, predefined fields that you probably need to capture, right? So here in this case, in our instruction, I have not provided what exactly I need. I have relied on LLM. You know, you go look at this image, find out everything. So this JSON structure is basically mind child of the LLM in this case, how to structure it. But this structure, you can provide it. Okay, these are the things I need, and this is how I need. I have shown you the example, how to give an example. So along with this instruction, you can also mention, okay, I need only the name of the candidate and passing year. So don't look at everything. You know? So I can do it like, only return in JSON format the below information. I don't need anything. That's inherent, basically. A bit of spelling mistake is allowed in LLM. So JSON format can be like this. It can be, I need the name of the certificate holder. It should be the key, and you are writing, okay, place the name here, kind of instruction. And then issuing date, you can place the date. You have seen that it has captured the date as it is written in the document. So I am writing a bit more. ISO date formatted, issuing date. So let's do this. I mean, just to have parity. I mean, it can have, we are dealing with multiple different certificates, probably, some certificates has a different date format, some certificate has a different date format. So don't extract as it is being viewed in the document, rather convert everything into ISO date format, which will be generic, and extract everything. So I just need these two pieces. If I craft the prompt in a way, let's see what it gives us, how good it is following. See? So now it is not extracting everything I have just mentioned, only this thing I need. This should be the key. Remained, right? Issuing date, converted into ISO date format, 8/2/2023, not 8 February, which was earlier. Never mind. So now you can parse this JSON, dump this data into MongoDB or somewhere, do whatever you need. So this is how you can also utilize directly images to LLM. And obviously you can understand, the extraction is inherent here. Otherwise, what we needed to do, without these multimodal models came into, when it was not there, what people usually do, they do it in two-step way. I mean, first load the image, extract information, use some OCR technologies there, extract the text, and then text-to-text model is what. But now with this multimodal image, multimodal model, you don't need to extract this text separately because LLM has capability of understanding what is written. You are looking at this. And handwritten pieces, handwritten signatures is being dealt with, is being dealt with by these LLM models nowadays, and Gemini is based in doing this, handwriting understanding. So probably we're dealing with a handwritten manuscript kind of, you want to digitize it. So there are many traditional models which were trained earlier just to translate handwriting to uh, uh, printed kind of format, kind of models were there. But the challenges was you cannot have enough number of training samples to train and customly build your model there. But these multimodal LLMs are trained in too many data that they by default understand what is written. And in a very bad doctor prescription kind of handwritten also, I have seen Gemini is extracting good. I can't compare the outcome though, because I am not understanding the what doctor has written in the description. But it was giving something looks like a very good medicine name, whatever. So these are the things that people can intelligently use in producing day by day or production ready services. So this is all for today. Within 1 hour, we could cover these pieces. Few things that I have covered was RAG piece, vector database, vector similarity piece, context, providing context and answering from that. Few examples of prompt best practices or a way to prompt engineering thing and multimodal LLM usage. All these codes are there. If you need, I can share this with you. That's all. I'm stopping here. If you have few questions, you can ask.
Yes, anyone, if anyone has any questions, please do let us know.
No, I guess. Cool.
No question, sir. That was awesome presentation. Can you please send us this Python notebook, sir?
Definitely. I would
Thank
want
you.
you to play with this Python notebook and create something on your own. Because all the
Thank
basic pieces are there. You just have to, if you are dealing with, say, 100-page document, probably sequentially running them inside a for loop won't be a good production ready solution. Right. Probably you need to do parallelization of the call. So these are extra tweaks that we can do and can play. So this Jupyter can be a starting point for you.
Yeah,
I will
thanks.
share it.
Thank you so much, sir.
Okay. Bye bye then, everyone.
Bye bye,
Thank you
sir.
so
Have a
much.
nice day.
Thank you
So,
so much, sir.
Thank you, Papa sir. Thank you.
Thank you. Bye.
so I hope everyone had a wonderful day today by exploring all the topics that we have taught today. So we will be sharing with you all these recordings by EOD today or by end of the day today or by tomorrow morning. So don't need to worry about today's recordings and all, and the course resources we will be getting from the mentors and uploading the same over the Educolab. So apart from that, there is one more announcement. As Shafila ma'am had mentioned in the morning, that you will be getting some practice assessments to get to know how on Educolab you will be giving assessments and aptitude tests like that. So there is an important update that we have uploaded few assessments on the basis of the sessions and not the whole course. So you can find the same over your Educolab when you go to the workshop section, and there in the particular classes assessment area, you will be getting the assessments, which is just for practice. No grading will be done on the basis of them. Just you can practice and keep a check of what you have learned in the classes. Right, ma'am?
Yes, Rakshita, if you can share your screen and give them a walkthrough where they